Math grade 12 trial 2021 paper 1 and memo. So anyways, this is basically what we are going through today. Now, to be honest, today I'm gonna try and behave. What am I gonna try and do? I'm gonna try and behave myself. You see, I'm gonna be normal for once. Anyways, let's see, and I'll try and explain a bit deeper because I don't know, why not, man? Why not? Let's see how it goes. Let's see how long this is gonna be if I'm like calm, collected, and I'm explaining everything in super duper detail. Anyway, so it says here solve for x, right? So when solving for x, we know that this expression has already been factorized. So already we know that 2x is either going to be equal to 0 or 3 minus x is going to be equal to 0. The reason for doing this is because you're multiplying two values, you see. The only way that this expression is going to be a 0 is if this is the 0 or if this is the 0, you see, because 0 times anything will always give you a 0. So potentially this could be a 0 or this could be a 0. We only do this if the right hand side is a 0. If the right hand side was like another number, like a 4, we cannot do this. We cannot say this is equal to 4 or the second bracket is equal to 4, you see, because that doesn't make sense, you see. This we only do it because for this expression to be a 0, either one of these can be a 0. So for 2 marks here, we know that this is going to tell us that if you divide by 2 on both sides here, x is going to be a 0. Or here you can see that the x can go to the other side, and then your x is going to be equal to a positive 3. You see, 3 is equal to x, or x is equal to 3. Same thing, nothing crazy, nothing major. The next question here, 1.1.2, these, they want us to round off to 2 decimal places. So you see, to try and make an example of what I had mentioned earlier, here if you take out x as a common factor, and you maybe do this, right? Here you're going to have 5x minus 4 equal to 2. You cannot say x is equal to 2 or the other. You cannot say, you see, this is factorized, so you cannot say this or this. You see, 5x minus 4 is equal to 2. You see, this is wrong. You see, this is wrong. So you cannot do it. So for this expression, you see, we already know that solving for x, we know that you can use the quadratic equation, meaning you can take everything to the left hand side and then you can just throw it into your quadratic formula. So here x is equal to minus b. Let me just write down the quadratic formula. B squared minus 4ac over 2a. So we know that this formula is like what? It's on your formula sheet, so it's really not like a big deal, like, you know, remembering it, whatever. So here x is going to be equal to minus b plus or minus, where's b? B squared minus 4ac. Anyway, so I normally I've been making so many of these like full videos that I've always started all of them randomly. But anyways, I am Levi from Bright Young Brains, and obviously if you want to download the PDF version of this file, you can, the link to that is in the description together with like the memo of everything that I'm gonna write down. And on IG, if there's any questions, you can just hit me up and ask what you think, or you can ask something on this paper, or you know, if you see like a small error or whatever, just hit me up, man. Look out for the boy, please, because I'm not gonna say I'm perfect and I'm not gonna make any mistakes, because I'm like ain't about to play those games, man. Life will humble you. So anyways, here if you put everything into the calculator, our two values for x, we're gonna get negative 0.35, or our x value is going to be 1.15. You see, that's to 2 decimal places as they asked right in our beginning. So 1.1.3, this is a normal question. It's out of 5, right? So questions like these where you have a surd, always try and put the thing with the surd on its own, you see, and then the rest on the other side. I hope this sound does not get into the mic. So carrying on here, we know that if you're gonna put this on its own, you can just leave it on the left, and then everything else you can just take it to the right hand side. So you're gonna have your negative 2x. So the reason for doing this is so that you can at least square both sides, because likely here you know that squaring both sides allows you to like cancel the square root symbol. So this is like 7 plus 3x, and then here negative 2 squared is a 4, this squared is a x squared. And then now you can use the quadratic formula by taking everything to one side. You see, it's usually easier to take everything to the side that has your x squared, you see, because I'm like, it's just how it is, you know what I'm saying? So here negative b plus minus all that. So here I'm just gonna put in the stuff, negative b plus minus b squared, so it's like b squared minus 4a, and then c there, and then here we know that this is going to be over 2a. Now putting all this into the calculator, let us see what we get over here. In the calculator, we know that we are getting x is equal to -1 or x is equal to 7/4. So x is equal to -1 or x is equal to 7/4, like that. So nothing crazy here, nothing major. But then the only issue is the 7/4 is not applicable. You see, this one is not applicable. The reason why is if you put 7/4 in your expression here, the two sides don't balance. But only if you put a -1 does your two sides balance. You see, you can even test it out. So 1.1.4, we obviously have an interesting also 5-mark question here. This kind of a question, just by looking at it, I'm already thinking of like the K method, because the K method allows us to like isolate something that looks crazy and then eventually simplify it or whatever. Like here, you see here we have this, we can break it up, right, to 3 to the power of x and 3 to the power of 2. The reason is here we know that if your bases are the same, you can add the exponents, so that's why we ended up with this. So this is just reversing that process. Same here, your bases, you have a base, this you're gonna put it to the power of 2, and then the other one you're gonna put it to the power of -x with the same base of 3, because here if your bases are the same and you're multiplying, you can add these two, which gives you that. Then here we have 82. So we can see here on the left, luckily it looks as though x to the power of 2 is a common factor. So I mean 3 to the power of 2 is a common factor, so you can take that out. So you're gonna have 3 squared here. Here you're gonna have 3 to the power of x plus 3 to the power of -x, and then this is equal to 82. So it looks like here we're not going to use the K method, because both sides we can just divide by 3 squared. So dividing both sides by 3 squared, we know that here you're going to have 82 with 3 squared here. This is just a 9, you see. So what are we going to do with this left stuff here? Let's see what 82/9 gives us in the calculator. I don't think it's going to give us anything simple looking, but let's see. Yeah, it's still just 82/9. So from here, I think you would want to think strategically. It is a 5-mark question after all, so you don't want to dive into it thinking that it's all going to be like, you know, all rainbows and sunshine and no glitches or whatever, because like what? But anyways, let's see. So what I would do here is what would I do actually? That's a good question. Also a very, very good question. What would I do? I'm trying not to panic. Yeah, okay, I don't panic. I'm just thinking to myself, let's put this over 1 and then do what? Get an LCD and everything. Yeah, I'm a bit against the idea of getting an LCD in this situation. I'm not even gonna lie. I am really not in the mood. I'm really not keen on getting an LCD here. But it is what it is. Yeah, let me just do what I would do in the exam without panicking, without wasting anybody's time. So obviously I'm looking at this paper for the first time, so, and I'm trying not to like, let's just work it out. Let's see, what did I do here? I'm thinking of putting 3 to the power of x over 1 and then like getting an LCD, but then at the same time I don't think that's gonna work. Let's see what I have on the left side here. On the left, right, potentially this is gonna be like 81 plus 1, and then this is like 3 squared, right? And then I'm thinking to myself, this is like 9 squared, which is like 3 to the power of 4 plus 3 to the power of 0 over 3 to the power of 2. I don't even know why I'm doing this, because everything is having a base of 3, and I'm thinking to myself, is that gonna make things easier for me or whatever? Let's see. This here is gonna be this. I can put it over the 3 squared. This I can put it over the 3 squared. And then what am I gonna have here? base is the same, so you can subtract here. This is going to be that. And then here base is the same, so you can subtract. This is going to be that. Ooh, damn. It worked out. I don't wanna lie, né? This was literally, I was thinking to myself, is this really gonna work out? And it looks like it kind of helped, because you see these match now, because it looks as though x is just a 2. Because here what I thought to myself was 82 gives you 81 plus 1. The reason I thought of 81 was because I was thinking of numbers that have a base of 3. Now this is like 9 squared, you see, of which 9 squared is the same as see here, 9 squared is the same as 3 squared to the power of 2, which is how I eventually went and got 3 to the power of 4 there. This, I thought to myself, it's a 1, so any base to the power of 0 is a 1. That's how I got the 3 there. And then here we know this plus this under the same denominator just means that this can be put over that, and then this can be put over that. And then here, since you're dividing right, your base is the same, you can subtract the exponents. That's how I got the 2. And then 0 minus 2 there gave me negative 2. And then on the left, everything on the left here is still just exactly the way it is. This would not change. So this would still be 3 to the power of x plus 3 to the power of negative x. And then here we can see 3 is here, 3 is here, 3 is here, 3 is here. There's an x here, there's a 2 there. There's a negative x there, there's a negative 2 there. So here we can basically then just say, therefore, x is equal to 2. You see? Therefore, x is equal to 2. That's how we have solved for x here. You know, when you may be thinking to yourself, what kind of a method is this? Is this like mixing and matching? Is this... it is what it is, you know. It is what it is. There are different ways to do the same thing. So, like you saw, I had gotten a bit stuck, and then I thought to myself, let me just do what I would do in the exam. And that's exactly what I would do in the exam. You see, just wing it and do things that are mathematically correct, and you'll be fine. Anyways, let's see what the next question says here. For 4 marks, it says, for which values of x will this be real? Well, for which values of x will this be real? Well, anyways, we know that this will be real when we know that this will give us like valid solutions, né? If what's under down here is a positive number, you see. The bottom part here, x squared minus 5x plus 4. This has to be bigger than 0. You see, bigger or equal to 0. You know, because that's the only way this expression is going to produce roots that exist, or that's the only way we're going to have like solutions. Because here, just working this out, this is not an issue. We can actually just get our roots by using the quadratic formula, or we can just, you know, factorize factors of 4 that can give us a 5. We know it's just 1 and 4, so here you can put a 1, here you can put a 4, and then you think to yourself, here this is a positive 4, so a positive 1 times a positive 4 can give you a 4, but then a positive 1 plus a positive 4 cannot give you a negative 5. So you want these two to give you a negative 5. The only way these two can give you a negative 5 is if you have negative 1 here minus 4. You see, negative 1 minus 4 gives you a negative 5. And then negative 1 times negative 4 gives you a positive 4 there. You see, that's how we factorized. That's how you factorize. You always use this number. You look for factors of this number that can give you this value, and then you drop those there. To get the sign here and the sign here, you saw that all we did was we said these two multiplied together should give us a positive 4. If you perform a normal calculation like plusing or minusing, it should give you the number in the middle there. So here we know that our x-intercepts, we know that it is technically going to be x is equal to a positive 1 because of this value here. So you're going to have a positive 1 over there, or rather, let's put a positive 1 over here and then a positive 4 over there, you see. And then in terms of answering an inequality, this is asking where is this graph above or equal to 0, and it's a smiling graph. So you know that you have a smiling graph like that, you can see that it is above 0 at this part over here and at this part over here. So this part over here, the part where it's like above 0, you can see that those are x values that are bigger or equal to 4. You see, the part where it's bigger or equal to 0, it's from 4 going to positive values that are bigger than 4. And here you can say x is equal to positive 1 and everything below positive 1. So here x is equal to smaller, x is smaller or equal to positive 1, like that, you see. And then this is your answer for 4 marks there. It's a 1.1 question. It's a normal inequalities question. Nothing crazy about this kind of a question. You just have to think normally, you know. Or do not panic. Anyways, so here it says that we should solve for x and y simultaneously if this is equal to 12 and if this is equal to y. So for 5 marks, we know that this question just requires you to be calm and collected and stuff. Because here, it looks like you can take this y value and throw it in there. That's what I think I would do here. Because like, why not? You know, it's already done for us. So here, this is equation 1. I'm going to label this equation 2. So throwing equation 1 into equation 2, we're going to have here x. Y here is x minus 4 equal to 12. Scenarios like this, just keep calm, just simplify nicely. Don't get too excited, because I'm like, what is the point of getting excited and then you lose marks for no reason? So here, this you can also do normal factorization, because I think I do use the quadratic equation a bit too much. So whenever I cannot, or whenever I don't have to, I think I should try not to. So here, factors of 12 that can give you a 4, I'm thinking of 6 and 2, because 6 times 2 give you a 12. But then here you have to be careful with what value goes here, what value goes here. This is a negative 12. So obviously these are going to have different signs, you see. And to get a negative 4, it technically has to be, this has to be a negative 6 plus a 2. Because negative 6 plus a 2 gives a negative 4. And the negative 6 times a negative 2 gives a negative 12 there. So we're factorized. So here x is going to be equal to 6, or x is going to be equal to negative 2. And then those two values for x, we know that for us to get the y values, we can just throw them in here. So here we're going to throw negative 2 as x, and then we're going to get y. So here y comes out as negative 6. Or if you throw in the positive 6 over there, you're going to have 6 times the y here. And then dividing by 6 on both sides, you're going to have y is equal to a positive 2. So this question, yeah, it doesn't seem like it was an issue at all. I think, it is what it is. Nothing crazy, nothing major. So let us keep on moving forward. So question 2 for 3 marks says, the pth term of the first differences of a quadratic sequence is given by this. So what they mean here is you have a quadratic. I'll explain this just now. Let's see here. Determine between which two consecutive terms of the quadratic sequence the first difference is equal to 1450. So what they mean is you have a quadratic sequence, right? Let's say you have a quadratic sequence here. This quadratic sequence, right? You know that it has a sequence of first differences. So this quadratic sequence here, you will have a sequence of first differences. You see, like a number here, a number there, a number there, a number here. This here, so let me actually label it. At the top here, you will have a quadratic sequence, you see. But then, these are your first differences, you see. These first differences, let's say here first differences. These first differences, they form an arithmetic sequence. The reason why they form an arithmetic sequence is because these numbers here have a common difference. You see, these numbers here have a common difference. Common difference. I don't know why I didn't give myself enough space. Like, this is not fair. So the idea here is our green part, the part that I've put in green there, you see, that's like an arithmetic sequence, whether we like it or not. You see, it's an arithmetic sequence that gets formed there. So here they said the pth term of the first differences. So as in a specific term in this sequence is given by this formula, in the sense that the arithmetic sequence that we're referring to now has this formula. TP is equal to 3P minus 2, you see. This is the general term of this sequence here. So if you're going to find any term in this sequence, you know that you can just throw in like 1, you'll get this position. 2, you'll get this value here. If you throw in 3 into the formula there, you'll get the term that goes in this specific spot. So here they said between which two consecutive terms of the quadratic sequence the first difference is equal to 1450. So what they mean is, if you look nicely, right, this is term number 1 and this is term number 2. Between 1 and 2 you have term number 1 in the sequence of first differences. Between 2 and 3 you have term number 2. Between 3 and 4 you have term number 3. Between 4 and 5 you have term number 4, going on and on and on. So in our case, we know that in the green sequence, right, let me actually color code this nicely so that it is more understandable. What we know is in the green sequence, right, we have the number 1450. So we need to find out where is 1450 here so that we can determine which two terms it's in between. So let us do that. We can just use our general term, because in our general term we know that we are looking for where 1450 is. To find where it is, we just have to solve for p here, so the 2 goes over. This is like 1448. No, you're adding the 2, maybe. Come on now, you're gonna add it when you move it over. So it's like that. Divide this by 3. Let's see, the 1452 divided by 3, you're gonna get 438. 484 actually. What am I so busy saying one thing and writing the other? But it's 484. So if you're going to get a value here that's like 484, or that's in position 484, it means that the term here is 484 and the term there is like 485. So here, to answer the question, let's say here we can say therefore the consecutive terms are 484 and 485. Questions that speak about the sequence of first differences. These kinds of questions, you have plenty of those in the sequences and series course on the course platform. You see, so on the course platform you have like different courses. A specific course will go through like the entire, let's say you have like a sequence and series course, right, that goes through everything on sequence and series that you need to know. Then there's like a probability course. There's like courses for all the topics that you need to know in grade 12, like, you know, courses on your entire syllabus basically. So I would recommend that if these kinds of questions are not, you know, very friendly to you, or you don't understand them well or something like that. But anyways, let us move on. 2.2 says the 40th term of the quadratic sequence is this value here. This is what term number 40 is. And then they said here, and this is the general term. You see, term number 40 is this, and Tn is equal to this. This is the nth term of the quadratic sequence. Calculate the value of C. And it's only a 4-mark question. So this kind of equation, don't just dive into it. Make use of this information here, because what they're trying to tell us is just visualize numbers around this for a bit. You see, what I mean is think of term number 39, term number 40, term number 41. You see, let's do this. T39, T40, T41. So what we know is T40 is 2290. The value after that we don't know. The value before that we also don't know. But then what we do know is that if you think of the sequence of first differences, let me actually make this a bit smaller. And you see, what you want to take note of what I'm doing here is I'm not even worried about C yet. What I'm mainly focusing on is visualizing the scenario, because if the scenario can be more visible in your head, it's easier to answer the question. So here, whatever term this is, we don't know. Whatever term this is, we don't know. Whatever term this is, we also do not know. So let me maybe put a y here just so that things look a bit more, a bit more okay. So anyways, what we do know is that the sequence of first differences, this value here, whatever it is, right, we can get it using the TP formula, 3p minus 2. You see, whatever this value is, this is just going to be 3p minus 2. This value, we get it by just saying 3p minus 2 as well, you see, because this, depending on what p is here, depending on what p is there, we're going to get the value here, we're going to get the value there. But for it to be maybe less confusing, let's just put TP here. What am I doing? I don't know. But anyways, yeah, let me just put this here. Actually, let me actually just leave this open for now. What I'm trying to do is, if they want us to eventually calculate the value of C, you may be thinking to yourself, don't they just want us to get like the what is this, the general term of the full equation, and then get C that way? Funny enough, not necessarily, because in this case, you getting the general term here, you need things like the first term and all that, of which that's just like too crazy. So yeah, this is, excuse me, this is out of fun, but I think this is one of the questions where a person genuinely needs to think outside the box. Otherwise, yeah, the doll is going to dance. So what I do know is, if this is term number 40, then we know that the value that goes here is going to be term number 39 of the sequence of first differences. The value that goes here is going to be term number 40 of the sequence of first differences. So in our sequence of first differences, we know that this is our formula over there. You see, in this formula here, we know that here we're going to have to put 3 with 39 here, and then we have minus 2 there. For this one, we would have to put 3 with 40 here, and then a minus 2. So we already know what this value is. We already know what this value is. Let's actually just get it. This is just, this is like, and as I am talking, you can see today I'm like quite relaxed. I'm not like rushing or anything. Let's see. So the value here is just going to be 115. And then the one after that, let's see here, 3 times the 40 there, going to minus the 2. This is going to give us, that one is like 118. So it's like 118 over there. So 118 and 115. So we know that the common difference in this sequence is, or the second common difference rather, let me maybe use another color then for the second common difference, because the pink represents the sequence of first differences, and then this is the common difference of the second common difference of the quadratic number pattern. So 118 minus 115, this is giving you a 3. Now what we know is, even though we're not going to eventually work towards getting the full general term here, I believe we can still get a value for A. I believe we can definitely still get a value for A over there, because, but then that's the thing, my only issue is, if we do get A, I mean, how does that help us to eventually get a B? Because, okay, let's not overthink it now. Let's think to ourselves, say we do have A, and maybe we don't have B. We could eventually then maybe get B and C simultaneously. And here's what I'm thinking. What I'm thinking is, since we have this 115 here, and we have this 118, we can easily get this value, or we can easily get that value. Because from all that we have explained now, right, we already know that 2290, if you add this 118, you should get a value for X over there, you see. So let's do that. 2290, if you add the 118, it should give you 2408. So here 2408. So you have T40 here, you have T41. So that's like 2 values that you can throw into this formula, and this can give us our value of a, because it doesn't matter what your second common difference is, it's always going to be equal to 2a. And then here you can see that our value for a is just 3/2. So from everything that we have spoken about so far, it leaves us with a scenario where our general term is just 3/2 with n squared there. We don't know what the b value is, and we also don't know what the c value is. However, we have two pieces of information that we can throw where n and tn is for us to work out b and c simultaneously. But so let's do that. So basically, the two pieces of information that we have is T40 and T41. You see, because what we have is where n is a 40, our Tn is like 2290. We also have where n is a 41, our Tn is 2408. I ran out of space. How did I run out of space? I ran out of the space. Let me put that down here maybe. Zoom in, write a bit smaller. So yeah, this question, I'm thinking to myself, the way I'm going about it, it looks like it's long, eh? But the idea is, when whatever you're going to be doing in your exams, if you see that what you're doing is valid and it's not mathematically incorrect and it looks like it's definitely going to give you the answer, then just go for it. Keep doing that instead of worrying about maybe there's an easier method or whatever. You see, you'll be wasting time thinking of an easier method, whereas you could just do what you know and get the marks. So here we're going to throw these one at a time into this expression and then make b the subject of the formula. We're just going to solve for b. So in this expression where we see Tn, we can put 2290 and we can put 40. So this is like 3/2 with the 40 there. Yeah, I do feel like I may have gone the long dry here. But again, this is definitely going to give us the answer. So let's just carry on. So here you may want to just make, I think it's easier to make C the subject of the formula. Because if you make C the subject of the formula, you end up with B only to work out. So let's see here, 3/2 with 40 squared. If you put that into the calculator, let's see what that gives us. 3/2 with 40, the whole thing squared. That's like 2,400. So this value, if you take it over, right, it's going to be 2290 minus 2,400. It's going to give you -110. And then this is equal to like, the b also goes over, so it's like -40b. And then this is what c is. You see, this is from you using the first coordinate, if you can think of it that way. So using the second piece of information there, let's maybe use a different color for that one. We're going to put 2,408 on the left side. We know that this is equal to 3/2. This is going to be 41 squared. We have b here, 41 plus the c. Now we said if you take everything to the left side, right, it's going to be this value in the calculator. Let's see what it gives us. 3/2. If you throw in 41 in the bracket and then you square it, that gives you 2,500 and something. So that value, if you take it over, it's going to be this value minus this one, ne? Let's see what that gives us. 2,408 minus that value, that's going to give you -113.5. This, you're going to subtract the 41b. This is equal to c. You see, this is like your second equation. Now from here, we know that we can just get a value for b by equating c equal to c. So here we know that c is equal to c. Therefore, the first part that we had gotten here, let me use a much more different color, like a green or something. So here it's going to be -110 minus 40b. This is equal to -113.5 minus 41b. Let's see, getting b here, you may want to take everything to one side, so it's easier to maybe take the -41b over so that you end up with like a positive number. You'll see, and then this number you can take it to the other side negative 113.5. You're going to add 110, and then here obviously you're going to end up with like b, because for 1 minus 40, that's like 1, you know, so it's like 1b. And then here negative 13.5 plus 110, you're gonna end up with like negative 3.5. So it's like negative 7 over 2 as your final answers. This looks valid, you know. As I said, whatever it is that we did. Wait, why did I work out a value for b when they want us to get c? This sucks. This sucks so bad. Okay, and it's fine. Here we could have isolated b instead, but it's fine. Here we got b. It's okay. Let's just throw it into any of our equations and then get a value for c. Like, I totally forgot that we were looking for c instead of b. But then whatever we did here is okay. It's still going to give us a value for c, because you can throw it into any of your equations here. Negative 110 minus 40. If you throw in a value of b, negative 7 over 2. Here you're going to end up with a c value of 30 if you put everything into your calculator. So you're going to have here negative 110. So you may be thinking, maybe it was a long drive. Not necessarily, actually, because the only thing I realized is what we could have done is to just make b the subject of the formula, and then when we equate the equations, we would be working out c immediately. But I just did it the other way around, but which is okay, because I'm like, we do have the final answer at the end of the day. I think the most important thing was the explanation in the beginning here. You see, that is what we mainly need to be able to do. If you can do that, then you will be in a very, very, very good spot. So anyways, let us just move on. Let us just move on with whatever it is that we are doing right now. Anyways, what am I thinking of now? Hey, I don't know what I'm thinking of me, but let me just move on. So, moving on. Question 3 is where we are at. For 2 marks here, they said, the first 4 terms of an arithmetic sequence are given. Determine the expression of the nth term. So this is as easy as it gets, right? Because I mean, like, for an arithmetic sequence, we know that Tn is equal to An. Yo, bosso, what are you saying? It's a plus n minus 1d. So getting the general term, all you need is a, which is the first term. So here a is like 65. D is the common difference. So it's like 73 minus 65. This is, I think, giving you an 8, but mental math is dangerous in exams. So let's get that from the calculator. This is definitely an 8. As long as you have a and d, you're done, because here Tn is equal to 65 plus n minus 1, and then your value for d. Here you may want to simplify, you know, just for z vibes. This is like 8n minus 8. And this is like 60. Let's just put Tn first. I mean the 8n first. 65 minus 8. Let's see what that gives us in the calculator, because why not? You know, why not? That's going to give you a positive 57. So this is like a positive 57. There's Tn over there. They'll give you 2 marks for that. Writing with white is kind of weird. I'm like, why you gotta do that, man? So many nice colors. I haven't changed these in forever. Yo. For 2 marks here, they said calculate the value of the term in the 1000th position. Wow, such 3 marks. So here where n is, we know we can just put 1000 there. This is like 8 times 1000. And then 57 over there. This is technically 8000 plus 57. So it's like 8057. Like, you know, such easy marks here. So don't lose these kinds of marks, because why? Why would you want to be that guy? 2 more marks. Calculate the sum of the first 1000 terms. What? These people. Wow, man. Wow, I guess they were kind of lenient with these ones, eh? Yo. I'm actually like proper shocked. But anyways, let's see. N minus 1 here, d. This is on your formula sheet. So the sum of the first 1000 terms, we know it's like 1000 over 2. The first term is 65. And we want the sum of the first 1000 here. So n is 1000. And then our value for d, we know it's our common difference, that's just an 8. And then what? Sum of the first 1000 terms. Let's put all this into the calculator. Calculator, please come and save us, because we have to get these values. So in the calculator, this is like 4,061,000. Is it 4,061,000? 4,061,000. Yeah, because it's like 3 and 3, so that is definitely 4 million. For 5 marks, wow, I hope I've given myself enough space. For 5, the mark says, it says here, an arithmetic and geometric sequence have the same first term, which is a 5. The common difference and the common ratio have the same value. And then it says that the 5th term of the geometric sequence is 80. Determine the first 3 terms of the arithmetic sequence. Arithmetic sequences, maybe there's more than one option. But anyways, the idea with these kinds of questions, or the idea with any math question, I feel like I've said this so many times, I don't even know how to say it differently, because I don't think there's a way to say it differently. When it comes to answering your math questions, never try and keep things in your head. Always try and draw something on your piece of paper. Write out something. Like here, they said you have 2 terms, you see. So picture the scenario for yourself. You have an arithmetic sequence and a geometric one. So you see, on the left here, I'm going to put stuff for an arithmetic sequence. On the right here, stuff for a geometric. They say they have the same first term. So this is like a 5, and then they have terms afterwards. This is like a 5. They have terms afterwards. Now, you always need to be able to visualize what an arithmetic sequence looks like. We already know that A gives you the first term. A plus D is the second term. Put A plus D here. A plus 2D is the third term, because you add the second difference. You add the common difference twice. And then you keep adding the common difference, you see. A plus 3D, going on and on. Let's just do it until the 5th term, because that's what they say it is also. What did they say about the 5th term? They said the common ratio is the same, and then, okay, no, let's just do this until the 5th term as well, because they've given us stuff until they've said something about the 5th term for a geometric one. So with this arithmetic one, if you're visualizing it, you know that first term is A, which is a 5 in our case. Second term, you just add D to the value of A. So here it's just, you can even just say here 5 plus D. And then here you add the common difference twice. And then here you add the common difference 3 times. And then here you add the common difference 4 times, you see. So this is term number 1 all the way until term number 5. And this is something you can do. Don't think to yourself, I'm only able to do this because I'm like good in math or whatever. That's like being lazy, Don't be lazy and think that certain things can only be done by other people. And then when you fail, you blame other people, like your teachers or whatever. But it's your fault, because you don't want to think and upgrade the way that you think about yourself. Okay, so change how you think first. Anyways, so the first value here is a 5, and then because this is a geometric sequence, you know that you have to multiply by r. So the second term here is just your first term times r once. Your third term, it's just you multiply r twice. Your fourth term rather, you multiply r 3 times, and then your 5th term, you multiply r 4 times. But then they told us that the 5th term of the geometric sequence is 80. So you know that this value here is just an 80. So visually, according to the information you're given, this is what your sequences look like. You see, they say an arithmetic and the geometric sequence have the same first term, which is a 5. So they all have 5 as the first term. So even if I put, I put T1, T2, T3, T4, and then T5. So it says here, the 5th term of the geometric sequence is 80. Good. And then determine the first 3 terms of the arithmetic sequences. So we need to determine these 3, meaning we just need to get a value for D. Now, obviously, this makes it so much easier for us, because here they told us that the 5th term is 80. So already we know that 5r to the power 4, this being the 5th term, we know that it is equal to 80. So this can give us r, of which the moment we have r, we also then immediately have the common difference because they just said it is exactly the same. So here you have to just be careful with the 4 here, because the 4 gives you 2 options as a value of r. Like here you can divide by 5 on both sides. You're going to have r to the power 4. This is just 80. No, 80 divided by 5, right? 80 divided by 5, this gives you a 16. Now the big issue is anytime you see that this number is an even number, it means your answer always comes out as a plus or a minus. Like if you put this with a 4 there, put this with a 4 there, and this always comes out as r is equal to plus or minus whatever you get here. So let's see. Shift square root, change the tiny 3 to a 4, put a 16 in your expression, you're getting there a positive 2. So this is giving you plus or minus a 2. That's your value of r. So here we can say therefore our value of d is equal to plus or minus a positive 2. That's why here they've said that we're going to have multiple sequences, because clearly you have 2 values of d, so each of them gives you a different scenario. So here where d is equal to 2, we know that you're going to have 5, and then d plus 5 plus 2 here is going to give you a 7. 5 plus 4 here is going to give you a 9. You see, this is sequence number 1. The second sequence, this is where d is a negative 2. If d is a negative 2, your sequence obviously starts with a 5. Here it's like 5 minus 2, right, which is going to give you a 3. And then here 5 minus 4, right, which is going to give you a 1. You see, these are the first 3 terms, or these can be the first 3 terms of this arithmetic sequence that they spoke about. You see, it's a 5-mark question, nothing crazy, nothing major. You can see what helped us was knowing what the structure of an arithmetic sequence looks like and the structure of what in a geometric sequence looks like. I think I swapped them around, but anyways, you see, this is the structure of an arithmetic sequence. This is the structure of a geometric sequence. So that is that. Let us move on then. Fantastic. So obviously you see these kinds of explanations. If you want deep explanations on stuff, remember the course platform, that's what it's there for. You see, that's what the course platform is there for. So don't be scared. Don't wait until it's too late. Just sign yourself up for like a month or something. That's all you need really. Anyways, let us move on. So this, you can see I've given myself like an entire page. It's a 7-mark question, and you just kind of need to be careful with a question like this one. This question, don't try and do everything at once. You see, just break it down nicely. And if you've watched tutorials, like for example on the course platform, like in the Zoom sessions package, there's a tutorial on sigma, where the big idea with sigma is this thing here is a specific number, this thing here is another specific number or an expression, and then this thing here is also going to give you a specific number or an expression. You see, all these 3, they give you something if you deal with them individually. So don't be scared because it's long and because it's a 7-mark question. So let's start off with this first part here. The first part here, they told you that you're adding up stuff starting from where p is a 1 until where p is a 5, and the expression that you have is just 4y plus 3p. So in a scenario like that, here you may want to, I think with this, because this is just 1 and 5, from 1 to 5, this we can actually visualize it for ourselves. Same here, this is just from the 4th one to the 7th one. So what I'm trying to say is here, all this means is wherever p is, we have to throw in a 1, a 2, a 3, and a 4 until a 5. So let's do that. For this scenario here, we know that this is just the same as 4y plus 3 with a 1 there. And then we're going to have 4y plus 3 with a 2 there. And then we do it until 5. And then 4y plus 3 with a 3. Let me write this a bit smaller so that it fits. Let's do this here, because I'm trying to give you an idea of like what sigma is and what sigma implies. Sigma just says you're throwing in p as 1 here all the way until 5, and you're adding everything up together, you see. So this is where you throw 1, 2, 3. Let's throw in the 4th one, 4 with the y here, and then here 3 with the 4, and then here 4y, 3 with the 5. You see, This, if you simplify it nicely, you can actually just put this into your calculator. The 3 times 2 going this, you're just adding stuff up, you see. So 4y, you have 4y plus 4y, that's like 8, plus another 4, that's like 12, plus another 4, that's like 16, plus another 4, that's like 20. So it's like 20y here. And then here in your calculator, you can just put in 3 plus 6 plus 9 plus 12 plus 15. You see, that is giving you 20y plus 45. You see, that is what this yellow expression has given you. Let's do the second one. Let's make it blue. This expression here, you see, it's saying you're adding up stuff starting from where k is a 4 until where k is a 7. The expression looks like this: 3 times 2. K here has to, this is like where the k is, this is minus 1. So you see here, you just have to start from 4 until 7. You see, you can even just use your SN formula for this one. The SN formula for like a geometric sequence. But anyways, if you want to do it manually, be my guest, which is what I'm going to do now, because it's like, it's just 4, 5, 6, and 7. It's just 4 numbers. So you see, this is like 3 with a 2, you're going to put a 4 here. And then 3 with a 2, you're going to put a 5 here. 3 with a 2, you're going to put a 6 here. 3 with a 2, you're going to put a 7 here, like that. So obviously this, you can just put it into your calculator, you know. It's nothing crazy, nothing major. So all this into the calculator, you could just have also used like, let's see here. So don't be scared, you know, of how, you know, you're going to be putting like a lot of stuff into your calculator and all that shondies. I mean, like, it is what it is, you know. 3 with a 2 to the power 4 there. And then we're gonna put 3 with a 2 there to the power of 5. And then 3 with a 2 there to the power of 6. Okay, all this into the calculator. It's nothing crazy. This is gonna give us 360. Fantastic. With the last one, that one we obviously have to use the sum to infinity formula. Here, the one that we just did here, you could have also just used the SN formula, because here your first term is going to be this, and then your value for r would just be a 2, and then you can put that in your SN formula for a geometric sequence. But I'm trying to emphasize how easy this is, even if you do it manually. So the sum to infinity expression there, you know it's a sum to infinity expression because of the infinity symbol at the top. We should add values starting from where j is equal to 1. Let me write our sigma symbol and our sum to infinity a bit better, you know, because, you know, why not? So here, this is 1/3 and then j minus 1. So like 1/3 j minus 1 over there. So this, we know it is equal to, this is just a sum to infinity, you know. It's just a sum to infinity expression. And in this case, looking at the way this is structured, you already know that your value of r is 1/3, and your value of a, you get it by throwing 1 where j is. But for a scenario like this one, if you're not sure what a and r is, you can just write out a few of these terms, like you see here, t1 and t2. Excuse me, you're gonna have here 1/3, right, with 1 minus 1. This is going to give you the first term 1. Here, t number 2, you're going to have 1/3 there. J is going to be a 2. And then here, you're going to have 1/3. You see, this is t2, this is t1. So your value of r is just going to be 1/3 divided by 1, which is just 1/3. Your value of a would be, is just a 1, you see. So obviously, we know that here, whatever you're doing here, you have a, you have r. So your sum to infinity, I'm not running out of space. I am, because I wrote so big here. Anyways, your sum to infinity here, it is just 1 over 1 minus 1/3. Let's see here, 1 over 1 minus 1/3. 1 over, let's say here in the calculator, 1 over 1 minus a third, this is giving you 3 over 2. You see, so you have here 3 over 2. There you go. So you have something for each of these. You see, you have 1, 2, and you have 3. It's all just an equation. You see, looking at it from what they gave us, we have seen that this first part here is just giving us 20y plus 45. This second part here, we have put that in blue. It is just 360. See, so they're adding 360. And then after they've done that, they've told us that this is all equal to 3 over 2. And then technically, us getting the value of y, we can just simply solve this equation over there. You'll see. So let us do it. Solving that equation, let's paste it here. So here we know this is more like a conclusion. So here we can say, therefore, this is our equation. Solving for y, everything can go over to the other side. We're going to have 20y is equal to, technically we're going to have 3 over 2, right? We're going to subtract 45, and then we're going to subtract 360. So let's do it nicely. 3 over 2. Let's subtract 45. Let's subtract 360. So this is giving us, what is this giving us? Negative 807 over 2. Negative 807 over 2. So y here, if you divide by 20 on both sides, divided by 20, our value for y is a bit of a strange value, but you know, sometimes when you've done all you can to get the correct answer, whatever answer you get, like it's okay, you know, just question it a bit, but don't think to yourself that it's like 100% wrong or anything, because I'm like, if everything has been done correctly, then you're fine, you know. Do not panic. Panicking is not the way. But anyways, let's see, let us just move on here. Question number 5. Let's see, the first thing here, it's a 2-mark question only, so that shouldn't be too difficult. We shouldn't overthink it in any way. This, we're clearly given a hyperbola, and we know that with a hyperbola, this gives us the x value of the asymptote, this gives us the y value of the other asymptote, because remember, all hyperbolas have 2 asymptotes, one cutting the x-axis, one cutting the y-axis. So here they said they want us to write down the equations of the asymptotes. So all you do is, your equation of your x asymptote, you always say it's equal to the opposite of this number, you see. So this is the equation of your x asymptote. The y asymptote, you always take this number as it is, which is just a positive 2, because the structure of your hyperbola, it always has a on top, this at the bottom, this on the other side, you see. So if you need more clarity on this, right, there's a tutorial on the main channel in the Zoom sessions playlist, because there's a playlist where I have like put in like tutorials from like one-on-one sessions and stuff. Let me actually just show it to you. So if I go on YouTube, where's YouTube here? Let's open YouTube, and I go to the main channel. Let's go here to Bright Young Brains. See, there's Bright Young Brains there. If you go on the Bright Young Brains channel, and you go to playlists, you'll see here there's this playlist here. What does it say? It says here, no, it is, yeah, Bright Young Brains one-on-one Zoom sessions recordings. There's this recording here. It's a bit lengthy, but it's a detailed tutorial on functions. You see, functions grade 11 basics. Let's see, functions grade 11 basic functions and graphs, full detailed tutorial. You're gonna go, it basically goes through all that you need to know about graphs. You know, it gives you the standard forms, what the standard form means, and all that. So for 3 marks here, they said determine the intercepts of the graph of G with the axis. So they want us to determine the intercept with the axis. So getting the intercepts with the axes, they are talking about, for example, this graph here, right? the intercept with the axis, you know that it is points where the graph has an x value for 0 and where the graph has a y value for 0, you see. So in the sense that your y-intercept, it's always where x is 0. This is going to give you the y-intercept. And then where y is 0, this is going to give you the x-intercept. You see, it's just like a rule of thumb. So because we have our equation here of g, our equation of g, we know it's like negative 4 over x minus 1 plus the 2 there. This is our equation of like g of x. So in this equation of g of x, for us to get the intercepts, we know that we have to take turns to either make x as 0 or make y as 0. So let's start with getting the y-intercept. Getting the y-intercept, we need to make x as 0. So here y is going to be equal to negative 4 over x. We said x, we have to make it as 0 to get the y-intercept. So this is 0 minus 1 plus the 2. This is going to give you a positive 4 plus a 2. This is just a 6. And then here, we know that you can make the y-intercept. You can make the y value as 0 here, right? So making y value as 0 here, you're going to have 0 is equal to like negative 4 over x minus 1 plus the 2. And then the 2 can go over. You can have a negative 2 there. Negative 4x minus 1. And then because this is over 1, you can just cross multiply here. You see 1 times that is equal to negative 4. This times the negative 2. You can have this as a bracket. Multiply in the bracket, you're going to have negative 2x plus a 2. And then because we want x on its own, I mean, like, you can take the 2 over. It's going to be, what is it going to be? It's like negative 4 minus 2. That's going to give you a negative 6. And then obviously dividing both sides by a negative 2, we know that you are going to have x as a positive 3 over there. You see? Nothing major. Nothing crazy, because I mean, we all know that yeah, getting the intercepts, yeah, that's not an issue, you know. You don't want to cry over those kinds of questions. So this was what? This was like 5.2. So the only issue is if they ask for the intercept of the x's, always give them as coordinates. Like here, this is the y value is 0. I mean, the x value is 0, the y value is a 6. Here, the x value is a 3, but then the y value is a 0. So always try to leave those as coordinates just so that you can be safe. You know what I am saying. So let's move on. For 3 marks here, they want us to sketch the graph. Now sketching the graph, always consider that an easy question, because firstly here we have the Cartesian plane. See, like that's as easy as it gets. So the first thing you want to put down is your asymptotes. Here we know that the first asymptote is x is equal to positive 1. So you see this is the x-axis. So where positive 1 is, you're going to have an asymptote there. So this is the x asymptote. This is the one that cuts the x-axis at 1. Your other asymptote is the one that cuts the y-axis at 2. So somewhere here you can see, you just want to make it proportional. You don't want to put like numbers here or numbers there. Just make it proportional and show exactly things like, you see here it says sketch the graph, show all intercepts to the axis as well as the asymptotes. You see, they just want to see the asymptotes and they just want to see the intercept to the axis. So the intercept to the axis, we literally just worked those out now, because here you can see it's a coordinate. X is a 0, y is a 6. So here x is a 0, y is a 6 would be like somewhere there. And then here x is a 3, y is a 0. So x is a 3, y is a 0 would be like, make it like somewhere there. You see, this is one x-intercept and that's like a y-intercept. Now to get the shape of your graph, again, this is all covered in like the basics of functions in the tutorial that I just referred to earlier. So your shape of your hyperbola, it's quite easy to draw, because all you need to know is what your value of a is. You see the number that is here, you see this negative sign here, it goes with the number on top, you see. So depending on the sign for your number on top, it's always going to give you an idea of like where your hyperbola should go. So firstly, I guess I have to explain this, but if your a value for your hyperbola is a plus, then if these are your asymptotes, you have to remember that we know that with all your asymptotes, there's this is technically going up, which is going up, we know you're plussing numbers. Going to the right, we know you're plussing, but then going to the left, we know you're subtracting. Going down, we know you're subtracting. So the idea is, if your a value is a positive number, it means that you're gonna have a curve over there and a curve over there. The reason for that is, you see plus and plus, so you have a curve there. Minus and minus, so you have a curve over there. But then if your a value is a negative number, then you're gonna have a curve over there because it's negative and plus, or you would have a curve over there, you see, negative and plus. So in our case, because we have a negative a value, see it's like a negative 4 there, it means that our curve is gonna be here, just as how our intercept suggests, and our other curve is going to be like somewhere here, you see, because this is suggesting that. Here, let me actually just maybe write this or draw this a bit better, because I'm like, you know, this is just a bit oogly. Well, it is not so nice anyways, but I think it's better, I see, because all they want is the shape and your arrows there. And then you're gonna get 3 marks because you have your asymptotes, the point there, you have the intercept, and you have the shape. That's gonna give you 3. That's gonna give you 3 marks. Nothing crazy, nothing major. So let's move on to question number 6. Question number 6, the first thing is out of 3, but forget the question. What does it say here? It says, sketched below are the graphs of this and this. So you have the graph of G, and then you also have the graph of F. So the graph of F here, we can see that this is just like a parabola. The graph of G, technically, I mean, like, this one is straightforward. Pun intended. It's just a straight line graph. That was a dumb joke. Well, I don't think that was a joke. It was what it was, you know. There's a straight line graph and a parabola. It says here, sketched below are the graphs of F and G. F and G intersect at B and D. So whenever you read something, always try and refer to the sketch as often as possible. I always say that. If you have heard me say stuff in previous tutorials or on like the course platform, yeah, the emphasis is you read something, go and look for it. Like here, they said they intersect at B and D. So where's B? There's B over there, there's D over there, because it's most like you're trying to get the information into your head, you know. That's how you get the information into your head. You read it and you go look for it. So here they then said that B and D are the x and y intercepts of G respectively, and they say, and yes, you see, this G is a straight line. There is its y intercept there, and there is the x intercept. And then it says here C is the turning point of F, and yes, we can confirm it on our sketch there. C is definitely the turning point of the parabola. And then it says here V is a point on G. Yes, V is definitely a point on G, and N is a point on the x-axis. N is a point on the x-axis such that CVN is perpendicular to the x-axis. You see, things like this, don't take them for granted. That's why when you read your question, don't just read, you know, it's not a novel, it's not a book, it's a description. But anyways, so here it says E. Where is E? You see, that's like automatic. They said E, and I want to know where E is. E is a point on G such that EC is parallel to the x-axis. So we already know this is a 90-degree angle because this is parallel to that. So it's going to cut the y-axis at an angle of 90 degrees because this is 90 degrees. You see, so if these are parallel, it means that these are corresponding angles. Anyways, it then says here A and B. Where is A and B? A and B, they've spoken about them. There's A over here, there's B over there. These are the x-intercepts of f. And this is how you want to read questions. Read and look at the description. So all this being said, for 3 marks, they say determine the coordinates of C, which is the turning point of f. The idea is likely we have the full coordinate. We have the full equation of f. So getting the turning point of any graph, we know that's like simple. All you have to do is to differentiate and equate your equation to 0. So here, f of x, we know that it is equal to negative x squared plus 4x plus 5. Now, we know that getting the turning point, you can just differentiate your equation to get the gradient equation. So this gradient equation, we want the turning point, and the turning point is a point where the gradient is a 0. So we're saying gradient should be a 0 so that we can find the x value where that gradient is a 0. Because the x value where the gradient is a 0 is going to be the x value of the turning point, you see. So here, dividing by 2 on both sides, we're getting an x value of 2. This is telling us that the x value here is a 2 and the gradient here is a 0. You see, this gradient being a 0, it is what has allowed us to determine the x value of the turning point, because a turning point will always have a gradient of 0. That's why to get the turning point, you differentiate so that you get a gradient equation, and then you make that gradient equal to a 0. So I've gotten the x value here to be a 2. To get the y value, we know we can just throw 2 into the equation of our parabola. The equation of our parabola is this main one here. So in that equation of f, where x is, we're going to throw in a 2 over there, and then we are just going to get an answer. So where x is, we've thrown in a 2. Let's see here. 2 squared is a 4, so this is like negative 4. I should just be using the calculator at this point, but it's too late for that. This is going to give you a positive 4 plus a 9, plus a 5. That's just going to give you a positive 9. If you leave it like this, this is a coordinate, but then most people would much rather just put it like that. You see, x value is a 2, and then y value is let's see 2 coordinate 9. 2 coordinate 9. What is 2 coordinate 9? That's the turning point. You see, nothing crazy, nothing major. 6.2 for 1 mark. They said you should write down the range of f. Getting the range of f, remember, range of f refers to which y values the graph goes to. So this graph has a y value of 9 over here, you see, and then it has y values lower than 9, you see. But then why am I getting a 9? Hey, I feel like I messed up here. I feel like I messed up good, but it's fine. No, it is a 9. What am I saying? So all the y values of this graph are below 9, you see. So that's the range of the graph. So you have to say here, y values have to be below or equal to 9. The reason we're saying equal to 9 as well is because specifically at 9, the graph has a turning point there. So the graph does touch 9. Moving on. For 4 marks here, they said you should calculate the length of AB. Getting the length of AB is the easiest thing ever, because you just need the x-intercept. Get the x-intercept there, get the x-intercept there, and then compare the distance. Getting the x-intercepts of this parabola, we can clearly see we can just use the quadratic formula, you know. You could say let's factorize, but hey, usually when there's like an a value of a negative, I just use the quadratic formula, because the quadratic formula, it's less hassle, you know. X is equal to minus b plus minus b squared minus 4ac, the whole thing over 2a. So you see, this is giving us an x value of the following. So in this case here, minus b plus minus b squared minus 4, a is a negative 1, c is a 5, and then a is a -1 at the bottom there. All this, you're getting an x value of -1, or our other x value is our other x value is like a +5, which is okay, you know, -1 and 5. So here you're going to put -1, here you're going to put 5. So just logically speaking, this is like 1 unit to the left, this is 5 units to the right. So the distance here is like 1 plus 5, you see, which is just 6. So here, therefore, AB is equal to 6 units, because you're looking at the distance from the origin. You see, this is like 1 unit to the left, 5 units to the right. So the distance is just 6 units apart. You see, nothing crazy with this question. You don't even have to overthink anything. 6.2 says determine the graph of G for 2 marks, or the equation of G for 2 marks. Getting the equation of G should be very easy, but at the same time we need to think nicely, because I mean, like, firstly here, getting the graph of G is just a straight line graph, so don't overthink anything that is like out of 2, because, like, you know, you're either gonna know what to do or just move on and not waste your time. So here y is equal to mx plus c. We need 2 things, gradient and the y-intercept. Fortunately, the y-intercept of this parabola is the y-intercept of our straight line graph. They also told that to us here. You see, they said here b and d are the x and y-intercepts of G respectively. You see, but then the b and d is also intercepts of the parabola as well. They didn't say that, but we can see it. So automatically it shows us, you see this 5 here, this 5 gives you the y-intercept of the parabola. So automatically we know that the y value of d is a 5. The x value is a 0, but the y value is 5. So automatically that gives us the y-intercept here. So here y is equal to mx plus 5. So far we just need the gradient, and for us to get the gradient, fortunately we have 2 coordinates that the graph passes through that we can use, because there's 0 coordinate 5 here, and then b, we know it is 5 coordinate 0. You see, 2 coordinates that we can use to get the gradient of our graph there. So you can label this x1 y1, x2 y2. So this is going to be like 0 minus 5 and then 5 minus 0, the gradient. You see the gradient, 0 minus 5 and then 5 minus 0. The gradient here is just a -1. And then here you can say, therefore y is equal to -x plus 5. Whew, there we go. Fantastic. Very nice, very nice. 6.5 says t is a point on F. So you think to yourself, where is t? T is nowhere here. So it means that the t that they're talking about, we kind of have to, like, you know, visualize it. But let's see. Let me just take this here and just move it to the bottom, because I'm like, why not, right? Why do we have to keep scrolling upwards like you know, like we don't have stuff to do? But anyways, let's see here. Let me just bring the image closer to us here, so that we don't have to keep scrolling upwards, because why would you want to do that? So with the image here, they said t is a point on F. Okay, I think I should have taken a screenshot of the plain one, but this is fine. T is a point on F such that dt, where is dt? There's d here, né? So it's a point on F such that d and t are reflections of each other over CVN. So CVN is this line. So if this is d, it means that t has to be on the other side there. So the x value here we don't know, but the y value is obviously a 5, because it's the same distance upwards and downwards. You see, if this is 5, a reflection on the other side is automatically going to be a 5. They want us to write down the coordinates of t. This is quite easy, because here you just have to remember that this is just a mirror image of itself. So if this distance here is just 2 units, you see, or rather, no, let's use this distance. You see, from here to the middle, this distance here is like 3 units. So it means from, oh no, I was actually on the right path. I'm sorry. If this distance here is like 2 units, it means that this distance here also has to be 2 units. You see, so if this is like 2 units to the right, this also has to be 2 more units. You see, so meaning the x value here is just a positive 4. So here you don't have to overthink this question. X is a 4, y value is a 5, because it's reflections of each other. So from here to there, if it's 2, it just means from here to there it also has to be a 2. So it's like 2 units plus 2 units, that gives you 4 units. Moving on to question number 7. Oops, my bad. Sorry. I thought we were moving on to question 7, but it's still 6. There's still more. There's like 2 more. Wow. Like 3 more. Whoa, it's like 1, 2, 3. Yo. The boy was ready to move on to question 7. Hey, yo. There was like moving on to question 7 so confidently. Anyways, let's see. Let's get some normal or weird colors here. Let's use this brown. Oh, this one. For 1 mark, it says the line EC is a tangent to F at C. Where is EC? The line, oh yeah, the line EC is a tangent to F, yes, at C. That's definitely true, because you see it's meeting it once there. So that being said, they said write down the gradient of this tangent. Well, the gradient is just a 0. We even said it without knowing. Okay, not without knowing, but we know it's just a straight line there. It has a gradient of 0 because it's a line that's like parallel to the x-axis. It's also a point that's touching the turning point of a parabola. You see, we know that a turning point of a parabola, or the turning point of any graph, the gradient there is a 0. So this straight line passes. Why am I yawning? Yawning and talking is not advised. Please just either do one thing. You either talk or you either yawn. So choose. I choose to talk. The gradient here is a 0 because this is just a horizontal line that is parallel to the x-axis. So nothing crazy about this question for 1 mark. 6.6.2, they want us to get the coordinates of E for 2 marks. So where is E? E is this point over here. It's for 2 marks. So the lucky thing is, remember, E is a point on the straight line graph as well. The y value here is a 9. So in the equation of the straight line graph, we're just going to throw a 9 where y is. And then it's going to give us the x value. Because you see this straight line graph here, the y value is a 9 there for the straight line graph. So that's why we're going to use the straight line graph to help us get the coordinate of E. So let us do it. Where y is, we're going to throw a 9. Where x is, we're just going to work it out. X is going to go over to the other side. Here you're going to end up with like 5 minus 9. This is just giving us -4. And then the coordinate of E is then going to be therefore -4 and a +9, like that. Moving on to 6.7 for 5 full marks. Here they say determine the value of K for which this equation is a tangent to F. Questions like these, don't think they are just random questions on their own. Because look, this question looks a lot like the previous one, or rather what you see here looks a lot like this. So this line that they're talking about, you can already see that it's just this equation of your straight line here. If this number is like altered, like if you move your graph up or down, your straight line graph is going to change this y-intercept. You see, this y-intercept changes if you move your straight line graph up or down. You see this straight line graph here, the gradient is a -1. If you move the straight line graph upwards or downwards, it's just going to change your y-intercept. Now, we know that if you're thinking of your straight line graph and the way your straight line graph is, let me just put it here so that I can explain a bit better. Our straight line graph, right? Let me even draw it here. This straight line graph looks like this. Oopsie, like that. Oh no, like that. So this straight line graph, this y-intercept is a 5. You see, it's initially a 5, which is representing the value of k there. But then when you move this straight line graph upwards, let's say somewhere there, it's gonna have a different y-intercept. And then if you move it upwards, there you see it's gonna have a y-intercept of 9. But then there's a certain point in time where you're gonna move your straight line graph upwards. It's going to have a specific y-intercept there. This specific y-intercept, whatever it is, it's going to be a specific value of k that will cause this line to be a tangent, because you can see here in this image, this straight line is a tangent to the curve, because you can see it will only be touching the curve once. But then if you move it any lower than that specific value, you can already see your graph is touching your parabola more than once, so it's not going to be a tangent. We want a specific spot where this straight line graph is going to be touching the curve only once. So what we know is, for this straight line graph to be touching our curve only once, we know that it is at a specific point where the gradient of the curve will be the same as the gradient of this tangent here, or this straight line. Let me repeat. For us to have this scenario here, we know that this here is going to represent a specific value of k. For us to find this specific value of k, we need to know what would the y value, we need to know what the y-intercept of this tangent would be, you see, because the y-intercept of this tangent gives us a specific value of k that would cause this line here to be a tangent to our curve. So in simple words, we just need to find an equation of the tangent to this curve here if that tangent has a gradient of -1, because a tangent that has a gradient of -1 to this curve is going to be a tangent that has a specific y-intercept here that would cause this straight line here to be a tangent to f. The wording is just a bit awkward, it's just a bit weird, it's just a bit but if you think of it nicely now, you just need to get the equation of a tangent to this curve here that has a gradient of -1, and then whatever that equation is, its y-intercept is going to be your value of k there. So I think that's the easiest way to put it. Get the equation of a tangent to this curve if that curve, or rather if that tangent has a gradient of -1. So getting an equation of a tangent to a curve, there are plenty of tutorials that I've put out on getting the equation of a tangent to a curve, so you can always just look at that. Because even if I go to like the channel now and I look under, why am I offline? Oops, the Wi-Fi was disconnected, but let me switch on the Wi-Fi. Yo, please load. Yes, please, intuitiveinc.co.za. Go check it out. Let's see here. Loading. This is like so annoying. Hey woman, let's go to Bright Young Brains. So if you check in the playlist, if you go on playlists, under probably the cubic functions playlist, let's see where the cubic functions playlist is. Yo, where is it? I don't know. Hi, the cubic functions, grade 12. If I scroll down here, you see determine the equation of a cubic function. Let's see, using the first derivatives, the equation of a cubic function. Yeah, you see, equation of a tangent to a curve. There's a tutorial on that there. You see, equation of a tangent to a curve. There are many tutorials on the equation of a tangent. Let me look in the calculus grade 12 playlist. You see here, equation of a tangent line at a given point. You see, you have tutorials on that on the main channel, so you can always look at that if you want to recap on getting the equation of a tangent to a curve. Anyways, the first thing you need to keep in mind is getting this equation of this tangent here The lucky thing is we already know that the gradient is just a -1. For you to get the y-intercept, I think that's where things get a bit tricky. But luckily, for you to get the y-intercept here, you just need a coordinate that graph would pass through. And this is this coordinate here. It's the point where the curve also has a gradient of like -1. So as long as you can find out what is the coordinate here where the curve has a gradient of -1, you can use that coordinate to throw in here and solve for k. So let's do that. In our original parabola, let's get the equation of this parabola. In this parabola, we need to find out a coordinate where the gradient is a -1. So let us do that. We need to find the gradient, or rather a coordinate where the gradient is a -1. To do that, it's nothing crazy. We just need to have the gradient equation of this equation. So the gradient equation, it's clearly just your first derivative, -2x there, plus 4. That's your first derivative. You want the gradient to be a -1, and then you want to solve for x. So meaning this can go over, and then solving for x, the 1 can go over. There's just a 5, and then x is equal to 5/2 like that. Whew, that looks okay. Yeah, x is 5/2. That's the x value. So to get the y value, you can just throw this x value into the original equation, because this has given you an x value where the gradient is a -1. So for you to find the y value where x is 5/2, all you need to do is to use the original equation. You see, in the original equation, you're going to throw in your x value as 5/2 there, and then you're just going to solve for y. So all this into the calculator. Let us see what this gives us. See, negative that, 5/2, going to square it, plus a 4, gonna have 5/2 as well, and then you're gonna have a plus 5 over there. So what now? This is giving you 35/4. 35/4 is the y value. So this is just 35/4. This is kind of accurate because you can see 35/4 is just below 9. So you see, this is the coordinate that the straight line passes through, because the straight line passes through this point here where the curve also has a gradient of -1. So this coordinate, we can use it to throw in there to find the specific value of k where all this is happening. So anyways, y here is 35/4, and the x value is just 5/2, and then k is k. So here, everything to one side and you leave k on its own. This is what you're gonna have. So here our k value is 35 over this plus the 5/2 there. Let's see, this is like 45/4. 45/4. So I think from the beginning, depending on like what I was saying, I was probably like just maybe overreacting, not a little bit, but I guess we should be okay now. So let us just move on. Question number 7. Looks like we're moving along just fine. Question 7 says, in the diagram, the graph of h of x. In the diagram, the graph of h of x is a log graph, and it is drawn below, as we can see here. It says here p is this coordinate there. It lies on h. Okay, nothing crazy here. They say we should find the value of a. Excuse me. I guess this is as easy as it gets, because this is just a basic straightforward question, you know. There's an x value here, and there's a y value directly next to it. So here, where is y? Y is a -1. So let's see here. Y is a -1, and we have log a. The x value is a half. So getting a value of a here, you have to think of what exponents look like, because remember, this will always be the base of your exponent. This will always be your exponent, you see. So, and then this will be left on its own. So your base here is a, the exponent is a -1, and then this is going to be left on its own if you like reshuffle it. The reason why you want to reshuffle it here is because that's the only way you're going to have A isolated, because now here you can easily just use your calculator, because in your calculator you can just put here a square root symbol with a -1, and then here you do the same square root symbol with like a -1 there, and then you just simplify because this is going to cancel that there, you see. So let's see here, shift square root symbol, -1, and then 0.5 over there. Then your A value here is a +2. 7.2, they said here or the following. We should write down the equation of equation of the inverse of H. That's what we should write. We should write down the equation of this, which is just the inverse of H, in the form y is equal to whatever. So what we already know is that this is the equation of our log graph. You see, one way or the other, this is the equation of our log graph, and we just have to find its inverse. Finding its inverse is really not a big issue, because the first thing you want to do first off is write this as y, and then you have log here 2 with x over there. And then what else? What you gonna do? Okay, so now you remember what we did here when we wanted to like solve for A. You're gonna do something similar here. This is the base, this is the exponent. You see 2 with an exponent of y, and then x is going to be left on its own. Wait a minute. No, bro, don't do that. No. Okay, wait, hold on. I feel like I may have done something to confuse you. These are both the same. You see, we have not done any inverse here. When you're going to perform inverse, we know that x becomes y. Let me write it nicely here. X becomes y, and then y becomes x. You see, that's what we know. So let's perform inverse. You see, so here we have performed inverse if this becomes x and if this becomes y. You see, this is inverse. So here we want to get y on its own, you see. So this is going to be the base, this is going to be the exponent. Base and then exponent, you see. Here you can then say, therefore, you can write the y first, just for the vibes. That will be for 2 marks, you see. Because here I was like, what? Y is already on its own. No, it's not, you see. I've just written this as y, you see. So that we can swap it around and then simplify. Because now we've performed inverse. But then they want us to have y as the subject of the formula. Moving on to the next question, they say we should get the domain of the inverse. So getting the domain of the inverse is quite easy, because firstly here, the domain of the inverse is the range of the original. That's how inverse graphs work, you see. Remember, with inverse graphs, the x and the y swaps around, yes, but then everything else about the graph swaps around, meaning properties of y swap with properties of x. So if you're going to need to get the domain of the inverse here, just think of what the range of this original one is. So the range of this graph here, we know that your y value is here. There's nothing stopping it from going all the way up. You see, there's no asymptote here going all the way up, and there's no asymptote going all the way down here. So the range here, we know that y is just an element of R. That's the range of the original graph. So it just means that the domain of the inverse would then be, the domain here would then need to be x as an element of R. Because remember, when you speak of domain, you always speak of R. But then this being the element of R, this is the range, right? It just means that the domain also has to be x as an element of R. Not to say you have to put y here for the domain. No, just think of what the range is, and then just swap this with an x, obviously, when you're going to be getting the domain of the inverse of the graph. You see, the domain of the inverse is the range of the original, you see, where you just swap around x and y, because that's how inverse is. You swap around x and y. So where you had a y over here, you will just have an x over here, you see. Where you had range over here, you would just have domain over there, because that's with inverse graphs. Domain and range swap around, x and y also swaps around. Moving on to 7.4, determine the values of x if the graph of h is smaller or equal to -1? And that's a 2-mark question. So, okay, where is h? Remember, the graph of h is this one. They're asking where is it smaller or equal to -1? This question is quite easy because this here, it is equal to -1. So they're asking where is it smaller or equal to -1? Like what x values is it smaller or equal to -1? That's quite easy. Firstly, it's smaller than -1 down here, you see, and those particular x values, it's from 0 until a half. You see, that's the part where it's smaller or equal to 0. So let's see what this so those x values, our x has to be bigger than 0, or let's write it in the way most people like to write it here. Most people would have said x is an element of 0 where 0 is not included until -1 where -1 is included, because you can see here this is saying where is it smaller or equal to -1. It's equal to -1 specifically here where x is like a half, and then it's obviously like smaller than -1 at between these x values here from 0 to like a half. You see, that's why we have said what we have said, and specifically at 0 it will never touch 0, so that's why 0 here is not included. Very nice. Let us move on. Question number 8. Oh well, I guess we're moving along very nicely. This is fantastic. For 3 marks here, they said ABC traders purchased a truck for 500,000. Okay. And the truck depreciates at 8.5% per annum on a reducing balance. Okay. And then they said here, determine the value of the truck after 12 years to the nearest rand. This is quite easy because firstly, the value of the truck is getting lower and lower and lower. So we use the reducing balance. Interest, they said it is 8% per annum. They didn't say compounded monthly, so it's just 8% like this. I always put the percentage symbol. You can put 8.5 over 100 if you want, or 0.085. And then here, so firstly, this value is getting lower and lower and lower. So the amount before time has passed is just 500,000. The amount after time has passed, we don't know. The amount of time that has passed is just 12 years. It's not compounded monthly, so it's just 12 as n. They say we should write it to the nearest rand. So here, getting our value for A, we know that P is 500,000. 1 minus the interest. As I said, I like to write the percentage symbol. And even when I was in metric, I would always just write the percentage symbol like this. And it was never an issue, or it's never an issue really. But anyways, here, let's put all this into the calculator. And then let me see what answer I am going to get here. 1 minus 8.5 shift percent here. And then the whole thing to the power of 12 over there. This, they say we should write it to the nearest rand. So this is just going to give you 172,196, like that. And then that is all you need to do for this question. You see, nothing crazy, nothing major. Yeah, it doesn't look like we are struggling here with this paper. This paper, it seems quite okay. It seems quite okay. Let me actually just double check some of my answers here, just so that I don't. Why am I double checking now? I could have just paused and double checked, but I'm busy double checking now. like bro, what in the world, man? What in the world? Anyways, everything looks all nice and dandy. 7.4, yes, my 7.4. Wait, my 7.4 looks a bit off. Yeah, where's the graph? Why did I put a 1? No, I meant a half. Ish, I'm sorry. I am so sorry. Ish. I meant a half, guys. I'm so sorry. Yeah. Ish. I'm pretty sure the comments came, but I fixed it. Okay, yeah. So for 7.4, it's between 0 and a half. Thank goodness I went to check because, oops, I'm so sorry. So yeah, don't be alarmed. The x values, you see, They were from 0 until a half over there. Whew, it's good to check, eh? Anyways, for 8.1 looks okay. No craziness there. 8.2.1 or 8.2 rather. Let's see what 8.2 says here. 8.2 is talking about Sipo. It says Sipo takes a bank loan to pay for his new car. He repays the loan by means of monthly payments of 3,300 for a period of 5 years. Okay, then he says that the repayments start 1 month after the loan is granted. You see, this idea of starting 1 month after the loan is granted, it just means that no payments missed. You see, no payments missed, because only a month after the loan is granted, that's when the loan is that's when you need to make your first payment. You see, before that you don't have to worry. Here it says calculate the this being said, they say the interest rate is 16% per annum compounded monthly. So with all this said, they said we should calculate the purchase price of the car if Sipo is granted the loan for the full purchase price of the car. Meaning, what does this mean? It means he didn't make any deposit on the car. Whatever the bank gave him everything, to pay off the car, or to pay for the car and then him pay back the bank. So it's a normal loan question, this one. So we have to use the P formula. P is equal to X and then 1 minus 1 plus I to the power of negative N, the whole thing over I. So the monthly installments, we know it's 3,300. The interest, they told us it is 16% per annum compounded monthly. So that's important. And he had it for 5 years, but then it's compounded monthly, so you times by the 12, which is a 60. And then what else do we need to know? P is the loan that he got. We don't know. That's what we're working out. So this is a normal P formula question, nothing crazy, nothing major here. P is going to be equal to 3300, 1 minus 1 plus 16% over 12. Always remember the percentage symbol if you're going to use the number 16. And then here the whole thing over 16% over 12. This, you're just going to put it into your calculator, you see. Don't worry about anything, because no biggie, nothing crazy here. This is not a difficult question. All this in your calculator, it is giving you 135,701.63. That's how much this loan is worth. They didn't say to the nearest rand here, so you can put it to 2 decimal places. This one, did I put to nearest rand? Yes, I did. Anyways, 8.2.2 says if the trade in value of his old car is 10,000. So him buying this new car, right? He's trading in one of his cars or his old car for 10,000 rand, and he decides to use this amount as the deposit. Your life, what a ripoff. Then he says you determine the new monthly installments that Sipo will now make. The monthly installments that Sipo will now make. Okay, well, this is quite an interesting question. It seems easy, but you have to be careful now, because his loan would have been 35,701.63. But then if he no, this is not even how you're supposed to look at it. This question is only out of 3, ne? But it's actually quite tricky. I don't even want to lie. Let's see. If the trading value of his old car is 10,000 and he decides to use this money as deposit, determine the monthly installment that Sipo will now make. Yeah, I don't want to overthink this question, but to be honest, yeah, this question we have to be very, very careful. We kind of have to be very careful, because it's not as straightforward as it looks. But at the same time, I would not want to overthink it. The reason why I would not want to overthink this question is because, why would you overthink a 3-mark question? So this loan of this car is this much, right? But then we know that if he makes a deposit of 10,000, then it means the loan is only worth 125,700.63. So this is the new p-value. This new p-value is equal to x 1 minus the interest, which is this value over here. It's still going to be for 60 months. However, we know that this is like 16% over 12. So solving for x here, I mean, I don't even know why I put all this like this. Let me actually not go against my own words and my own thinking. So this here, we know that this is the loan amount for the car. Yes, we need to work out what the new monthly installments would be. So this here, we said this is going to be a value of p, right? But then if you're going to work out monthly installments, remember I always say isolate the value of x. So here, let's do it. Here, this is what our p formula looks like. But then we need to isolate the value of x. So isolating the value of x, we need to multiply by I on both sides. This is like 1 minus 1 plus I negative n. And then here we need to divide both sides. So this is like pi. This is just like 1 minus 1 plus I to the power of negative n, like that, you see. And then this is what our x value is. So working out a value of x here, we know that p, you're just going to throw in your 125 and just 701.63, and then your interest here, it's just 16% over 12. And then here, let's see, this is just 1 minus 1 plus the interest is just 16% over 12, and then n is going to be a negative 60, like that, you see. All this you're just going to put in the calculator, all nice and dandy, nothing crazy, nothing major. So the value of x here is just going to be 3056.82. Whew, doesn't seem like a big saving, to be honest. I don't even want to lie. But anyways, let's move on to 8.2.3. For 4 marks, it says calculate the savings that he'll make if he pays the deposit of 10,000. Well, I mean, like, this one is a simple question. I don't even know why it's a whole 4 mark question. But let's not underestimate the question, you see. So let's see let's just compare how much he will pay in both scenarios. So in scenario number 1, this person will pay 3,300 over 60 months. This clearly shows that in that scenario, this person would have paid 198,000. Okay, but then scenario number 2, this is what he would have paid. He would have paid the 10,000, right? And then he would have paid 60 payments of 3,056.82, like that, you see. So let's see what this would be. This would be like 10,000 plus this amount over here. Let's see, 60 times 3056.82, right, like that. So this would be like 183,409. Why didn't I just put everything in the calculator at once? Hey, let's add the 10,000 there. Let's see, this would be 193,409.2. So clearly he pays less if he does the deposit, but then the price difference is just, let's see, the difference in how much he pays is just this much. So let's see, 0.2, this minus that, let's see what that gives us in the calculator. This gives us a difference of 4,590.8. If you're going to write it to 2 decimal places, you can put like a 80 if you want. It's really not an issue. So It's so good, it's so good. Moving on to question number 9. Here we are at question number 9. Question number 9 is a straightforward 5-mark question. It's a, first principles question, so nothing crazy, nothing major. With this first principles question, right, we know that, this one is quite crazy. It's like a whole quadratic equation. But the one thing you can do for yourself is just see what it looks like without using the first principles. You see, if you use the power rule, which is the short way of differentiating, you're just going to end up with 2x plus 5. You see, this should give you an idea of what you should end up with. So just keep that in mind. But then this won't give you any marks, you see. If you're lucky, you'll get 1. But then here they said we should use first principles to answer this question, meaning we have to use that long formula. So using the long formula, we know that we have to do the following. Here, our f prime is just equal to lim h goes to 0, f of x with h there, and then minus this. See, f x h, and then over h. Yeah. What I normally do is always, before you use this formula name, you know what f of x is. F of x is just what you have over here. But then this value, just get it first. Like simplify, like on your answer sheet, work out what this value is first, and then throw it in there. You see, let me actually use a different color, just for the vibes. So let's see this here. Now you want to see what this is. This just means wherever x is, you have to throw x plus h in this entire expression. So here where x is, you're gonna throw x plus h. That's why we're gonna square it there. 5, and then you have x plus h there, and then a minus 6. So here you're gonna just FOIL out everything. You see, it's like x plus h, and then 5x plus 5h minus 6. Then here you know that x times x is like x squared, and then x times h is gonna give you xh, but then when you do it again, you have 2xh, you see, and then h times h is just h squared. You see, that's just foiling here. Then here 5x plus 5h minus 6. There you go. This is what you're going to put where you see this over here. So let's actually just color code it like we have done for the others. You see, done. So now let's just throw everything into the formula. You see, it makes it less cluttered if you do that. So into our f prime formula, we know that lim h goes to 0. Where we see this here, we can just throw in this entire thing over here. I have the limit of just copying and pasting, like make this a bit smaller, throw this here, and then our equation of f. So because you're minusing, let me actually just do this. You see, you're going to minus this thing here. Just be careful. Squared plus 5x minus 6. And then let's put the whole thing over h. You see, there you go. Nothing crazy, nothing major. So this kind of a scenario, all you have to do here is you have to multiply the x, the negative inside, you see. So nothing crazy here. 2xh plus h squared plus 5x plus the 5h minus the 6. Here you're just going to minus everything. So the easiest way is to just remember to, whatever you do, don't make silly mistakes for these kinds of questions, because it's like 5 easy marks. So at the top, stuff has to cancel out. If things don't cancel out, you have done something wrong. You see, this cancels this. There's a positive 5x, a negative 1. There's a negative x, 6. There's a positive 6. So what you'll be left with is technically just lim h goes to 0. This is like 2xh plus h squared plus the 5h. And then here technically what you got, there's h down here, and then now you can take out h as a common factor, because your goal is to take out h as a common factor one way or the other, so that you can have something where you can throw in a value of 0 where h is, without getting an expression that's like undefined. So at the bottom, if you take out h, it's just going to be 1 left as a placeholder. the h's cancel each other out, and then you're gonna have now lim, hey, what am I saying, him, lol, okay, that was not funny, lim h goes to 0, and then now you have 2x plus h plus the 5, and then now you can throw in a 0 where x is, where h is. So it's going to be this with a 0 with a 5. Therefore your first principles is just 2x plus the 5. See, just like what you have here. You see, this is going to help you to see, okay, wait, what you've done is actually correct and there are no issues. So let's keep it moving. 9.2, you need to just differentiate here. They didn't say anything about first principles, so you can just use the short method, meaning simplify first. So simplifying first, you may think, let's multiply inside. Yes, we can, but why don't we just change this first, you see, to something that we can recognize. Remember, there's a tiny 2 there, there's a tiny 1 there. The tiny 2 just goes under the 1 there, so that's why this is a half. That's how you simplify surds. Because if you had, let's say, a surd here with x, let's say x, and this was like a 4, no, let's put a 5. This, you have to remember, if there's no number here, the number by default is like a 2. But if there's a number here like a 3, if you want to simplify this for you to be able to differentiate it, the 3 goes under the 5 there, and then you'll have something like this. So here in our case, there's no number here, so it's a 2. There's no number there, so it's a 1. So the 2 just goes under the 1 there like this. The reason for doing this is we're trying to simplify first before differentiating. So simplifying, you can multiply inside. Here you're multiplying 3x times this. You know that for the x's, the bases are the same, so you can just add the exponent. So here 1 plus a half just gives you 3 over 2. And then here this multiplied by the 4 there is just going to be negative 12x. So you have simplified as best as you can. You see, it's still just f of x. So because now we are going to differentiate, because now it's in a format that we can differentiate, we can now just use the normal power rule. You see, this times the value here is just going to give us, 3 over 2 times 3, that's just 9 over 2, you see, and then this minus 1, that just gives us a half. Yes, it does. And then here we have 1 times a negative 12, that's just a negative 12, and then 1 minus 1 at that, here it's just going to be a 0, you see. So anything to the power of 0 is just a 1. So we know that this, we don't even write it out, you see, because it's just 1 times negative 12 is just negative 12. And then x to the power of 0 is just a 1. You have differentiated, you see. They'll give you 3 marks, nothing major. Okay, it's okay. Moving on to 9.2.2 for 4 whole marks. I think I gave myself the whole page here. I don't even know why I was being so extra. But with a scenario like this one, you obviously just need to simplify first. Here, it looks like you can take out x as a common factor first. And then the thing is, you actually end up with the difference of 2 squares here. Because normally when you see a fraction, the bottom should always be something that you can cancel out. So you see here, this is just the difference of 2 squares. So you're going to have 2 brackets here, where you have x and x, which is the square root of x squared there. And then the square root of 4 is just a 2. And then this minus tells you have to put a plus and a minus over there, because that's the difference of 2 squares, you see. It's just going to be the square root of this, the square root of this, and then one has a plus, one has a minus. At the bottom, you see this looks a lot like this. So you may want to swap around the x and the 2. And then here you can take out a negative as a common factor at the bottom. So let me just write the top first. And then at the bottom, you can take out a negative as a common factor. So if you take out a negative, you're going to have x as a plus there, and then that as a negative 2, you see. And then that allows you to say this bracket cancels this bracket. So you're going to have negative x with x plus 2 over there, because here you're just going to be dividing by a negative, you see. So it just means that you can just put the negative in front there. Or rather, let me write it like this first, and then just, so this is just divided by -1. So this being divided by -1, I mean, like, just think of it as though it really, don't overthink it. If you're dividing by -1 here, you can just put the negative in front over there, because technically everything is factorized here, and then just dividing by negative allows you to just write it like this. Don't overthink it. You could even ask, but why would you do that? It's just how it is. You dividing by negative just means that you have a negative there. You see, it's just how it is. It's just how it is. It really is just how it is, like, legit. So if you're really like curious as to why it's like that, then you can think to yourself, I mean, like, one way or the other. You could think to yourself, at the top you can take out a 1 out as a common factor at the top. You see, if you take out a 1 at the top, then at the bottom you can also take out what, or rather at the top you can even think of it as +1 times a -1. This represents a 1. At the bottom you could think to yourself, I think that's just overcomplicating it. I'm not going to overcomplicate anything. Just remember, if it's divided by 1 down here, you can just write it at the top like that. You see, there we go. Whew, okay. So now what? Yeah. Don't know what. Yeah, anyways, carrying on, that this, you can multiply it inside. It's going to be -x², and then -2x, like that. So you see, you have not simplified. You've not differentiated. I mean, you have just been simplifying. Everything here is just equal to y. So now what? Now we can differentiate, you see, of which us differentiating now is just using the power rule. So now you can put dy over dx here, and then you're going to have 2 times the negative there. It's going to be -2 with the x there, and then removing 1 from the exponent, and then here 1 times the -2 is just a -2. Removing 1 from the exponent, the x is gone. There you go. That's the way. I like it. That's the way. I like it. So that was not bad at all. It was just like, wait, but I need to, yeah, everything is fine here. Let's move on. Question number 10. Let's see how far we are from the finish line. Oh, there are 12 questions. 13. Oh, I'm so shocked. Hey, it's fine. Question 10 says, the graph of f is this, ne? And they said a is not equal to a 0. Duh. I'm like, a is a 1, you dumb. I'm like, we can see it. Yeah, these people trying to be extra. Anyways, they said here, yeah, it is sketched below. And then it says here, a is this coordinate here. Just that part over there, yes. I feel like you've seen this. These people, they like questions where your cubic function has an x-intercept at a turning point as well. It's like their thing. But anyways, it is what it is. It says here c is 0 coordinate 4, and it is the turning point. Yes. And then it says here it is the turning point, and b is both the local minimum and the x-intercept. Yes, we already said that. For 1 mark, they want us to write down the value of d. The value of d is the y-intercept. You see, that one is quite simple. D is just a 4. Nothing major, nothing crazy. Nothing major, nothing crazy. Yeah, it is what it is. I feel like it is what it is so overrated. Not overrated, it's just I abuse it too much. Yeah, ne? I'm sorry. Okay, for 4 marks, they said we should show that b is this and c is that. Well, that's not too difficult. It's not a difficult question at all, actually. We should just get b and c. Getting b and c here is quite what is it? Is it easy? It's okay. Why is it okay? Okay, so firstly, now, whenever you get, technically they want us to get the equation of this cubic function. So technically this cubic function, so far we have f of x is equal to x cubed plus bx squared plus cx plus 4. This is what our equation of our cubic function looks like so far. Anyways, this being the equation of the graph, right, what you have to recognize is when this equation here is like factorized, right, we need to keep in mind that as long as your x-intercept is where your graph also turns, anytime you factorize an equation like this, this is what the factorized expression will look like. Your factorized expression will always have 3 brackets, right? However, 2 of the brackets will be exactly the same, and the 2 brackets that will be exactly the same, they will always be representing this x-intercept that is also a turning point. So this here, we know it's a positive, it's a -1, right? So it means that one of your brackets is going to be x plus 1, and then you're going to have your a value in front over here, and then here you're going to have, let's just put here minus x1 and then minus x1, let's say actually x2, to represent the other x-intercept. So let's say here x2 minus x2. So the big idea here is a, we know it's a 1 already, so this is just sorted x plus 1, x minus x2, x minus x2. Let me actually write this x2 as like a variable like k, so that it's a bit easier for us to, like, you know, work out whatever it is that we're trying to work out. And I'm sorry if you're writing along, man, I'm busy saying stuff and I'm busy changing, I'm sorry. So these 2 variables here, or the variable k, represents the x value over here. You see, whatever this x value is, let's label it k. So it means that here we have to put minus k and minus k. So the big idea here is, this is what f of x is. So if you multiply out f of x, right, if you FOIL out everything here, you're gonna have x plus 1 outside, and then here x times x gives you x squared, x times a negative k gives you a negative kx, and then again you're gonna have a negative kx, and then here you're gonna have k squared, right? And then simplifying some more, what you're gonna have is gonna be x squared minus 2kx, and then positive k squared over here. This is equal to like f of x. And then we know that if you simplify some more, x times x here gives you x cubed, x times that here gives you 2kx squared, and then multiplying again gives you like k squared x, and then 1 times the x squared, and then 1 times that, negative 2kx, and then k squared, like that. Okay, I feel like I'm running, you know. I should calm down, bro. Calm down just a little bit. Anyways, from here, what can happen now? Yeah, from here, the big idea here was, let me just make sure I didn't make any mistakes. I don't think I did, but might as well. Why did I give myself so little space though? I don't understand, man. Why would I give yourself so little space? Like, what is that? What are you trying to save the space for? Anyways, so you see here, the reason for us having to have done this, is because you just want to eventually mix and match stuff, you know, meaning whatever you have now is what's going to help you to get your value of b and c, because you eventually just want to mix and match. This x to the power of 3, it's on its own, but then the stuff that has x squared, you have 2 of them, you see. So let's put those together, 2k x squared, and then this here x squared. The stuff that have x, let's put that together, and then the stuff that does not have x, let's leave that on its own. You see, that's k squared. So here we can clearly see that d is being represented by k squared over there, and you can imagine why they asked us to get a value for d here, because technically whatever you see here, right, this is what's representing your value of d, because look, this is going with that, this is going with wait, I forgot to put the squared there, I'm sorry. Ish, this is annoying, So yeah, these 2 here go with the bx squared there, these 2 here go with the cx, and then the something that does not have x here goes with the 4, you see. So here we can say, therefore k squared is equal to 4, and then technically, I mean, like, what we can think to ourselves is k gonna be a positive 2 or a negative 2? That's gonna be, that I think is technically the tricky part, because I mean, like, one way or the other, right? Technically here k has to be like a positive number, of which the only positive number that is viable there is like a positive 2. So here k is going to be equal to a positive 2 if you square it both sides. So if k is a positive 2, automatically that gives us a value to throw in over there that can eventually give us a b value, and a value to throw in over there that can give us a c value. So let us just do it. Let's see here. If k is a positive 2, it means that therefore if you throw a 2 there, you're gonna have negative 2 with a 2 there, with x squared plus that squared. So this is going to give you negative 4x squared plus x squared. This is going to give you negative 3x squared. So here, therefore, b is a negative 3. And then you use the same analogy for c. This here and yeah, this here, right, and this here is what contributes to your c. So here you know that 2 squared x minus 2 with a 2 there where k is, if you throw x there as well, if you simplify this, you're gonna have 4x, right, minus what, come on man, yeah, this is perfect. This is giving you 0x, you see, therefore c is a 0, because what we said was, let me actually just color code it so that you can understand better. The stuff that has x squared, you see, this here is what contributes to your value of b. And then the stuff that does not have x squared, like the portion that has x on its own, this is the part that contributes to your c value, you see. And then this part contributes to your d, this part contributes to your a. So that's going to give you how many marks? 4 marks. Fifth, 10.3 here for 4 marks, it says determine the equation of a tangent to f at x is equal to f5. So equation of a tangent to a curve, I mean, like, that's like easy stuff. X is equal to a 5 is probably going to be somewhere there, because if this is a 2 going to the right, 5 is going to be somewhere there. So we need to get the equation of this tangent over here. The idea with the tangent is, we know that a tangent is just a straight line graph. So you see y is equal to mx plus c. We just need its y-intercept and its gradient. So its gradient, we can get it by getting the gradient of our parabola where x is a 5, you see. In our gradient equation, we need to throw in 5 as the gradient, or no, we need to throw in an x value of 5 into the gradient equation. That is going to give us the gradient where x is a 5. So our f of x, we can clearly see that, let's just get it here and then throw in our b and our c value as we have already gotten it. So let's just do this here. Let me just now, how I just put you over there, why are you coming back? Yo, this thing rebellious, man, rebellious. It's being uh-oh, I think I broke it. Uh-oh, I did break it. Sure. Anyways, let's see what we have here. F of x is equal to x cubed. B, we worked it out to be negative 3x squared. C was a 0, so this is just a 4 like that. And then what do we need now? Let's see. So here we need to, this is our f of x function. If you differentiate this function, let's see what you have here. 3x squared minus 6x. This is what your differentiated expression looks like. So this being your differentiated expression, we know that you want to work out what is the gradient where x is a 5, because the gradient where x is a 5 gives you the gradient of the tangent. So let's see here. We want a gradient of, we want an x value of 5. We want to find out what the gradient is where x is a 5. This is a 5, you're gonna square it, and this is a 5. This is 5 squared, which is like 25, times 3, that's like 75. And then 6 times 5, that's just like a 30, I think. Is it? Yeah, I think so. Anyways, it is what it is. Whew. So this is telling us that the gradient is 45 where x is a 5. I know that looks a bit strange. Well, it is. I'm like a whole 45. Like, go do ness, you know, like go do the ness. But that's what you're getting, you know, and don't doubt your answers, you know. Gradient is a 45 and we just now need a coordinate that the graph passes through so we can get our y-intercept. So a coordinate that the graph passes through, you can still also get it by throwing in a 5 into your original equation of f of x. You're going to get a coordinate that the straight line graph passes through, because of which the straight line graph is, you know, the tangent that we're talking about now. So anyways, let's see here. In our normal f of x function, we're also going to throw in a 5 because we want to find out what the y value is there. So in our normal f of x function, which is this one here, where x is, we're just going to throw a 5, not a 3, maybe a 5. Just like 5 cubed here, and then 5 squared there, then a 4 over there. All this into the calculator. Let's see what we get. 5 cubed minus 3 with the 5 there, and then squared over there plus the 4. That's like 54. So this is like 54 f with the 5 over there. Now this is a coordinate that you can throw into your straight line graph equation, because in your straight line graph equation, remember we have y minus y1 is equal to m and then x minus x1. So here y minus the y1 here is like going to be 54, gradient we got 45, and then the x value there is like a -5. I mean there's a 5 but you put a 5 there, so but there's a negative here. Simplifying, we're going to have 45 x minus, what am I doing? Why am I being jajarach, man? Huh? No, I'm not being jajarach. The 45, let's see, what is 45 times 5? 45 times 5 is like 225. So this is gonna be like 45x minus 225 plus 54. Y is gonna be equal to 45x. Let's see here, negative 225 negative 225 plus 54 is like negative 171. Hey, I can do better, man. Come on. Minus 171. That's the way. I like it. Nothing crazy with this question. 10.2 for 2 marks says, for which values of k will f of x equal to k have 2 unequal positive roots and 1 negative root simultaneously? These kinds of questions, I genuinely recommend that you check out the course platform, the functions and graphs course to be specific, because those kinds of questions are plenty in there. Here it says you need to determine values of k, right, for which f of x will have 2 unequal positive roots, okay, and 1 negative root. So that kind of a question, or this kind of a question rather, it needs you to visualize the graph, or you just need to look nicely here. If you're going to have 2 unequal positive roots and 1 negative root, firstly this graph here, let me just do this, do this, go down. Let's see here, this, oh no, oh no, oh yeah, this is perfect actually. No, it's not. Let me just go back. No, man, go back, come on, man. So if you take yeah, let me actually do it like this, do it once, and then so that I can just grab it once. So you see, this is what the cubic function looks like. You see the way it is now, it has 1 negative root and then 2 equal positive roots. Okay, 1 negative root, 1 positive root. I don't know, I said what I said there. So this being the scenario that we have, right, you're gonna think to yourself, for your graph to have 2 unequal positive roots and 1 negative root, you have to think to yourself, this graph technically has to be either moved up or down, or rather in this case it can only be moved downwards for that scenario to happen. Like if you move it downwards like now, you see, and you keep moving it downwards, you can see it still just has 2 roots that are positive and 1 negative root. if you keep moving it downwards, right, and you keep moving it downwards, 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 or eventually it's going to have one positive root and one root that is equal to 0. But just before that scenario, it still has one negative root and two positive roots over there. If you were to move it anywhere upwards, let's say above this, it only has one negative root over there, and it has no positive roots at all. So for us to make sure that it only has two positive roots and one negative root, we know that we have to move it downwards. So starting from 4 here as the y-intercept, we can move it downwards all the way until we can move it downwards a maximum of 4 units, you see. Because if you move it down a maximum of 4 units, your scenario of having 2 roots, you don't have it anymore. But then just before moving it 4 units maximum, we know that you still have 2 roots there that are positive and 1 root that's a negative. So what you want to think to yourself is your value of k, right? If you think of f of x we know it is equal to x cubed minus 3x squared minus 3x squared, and then you have a plus 4 over there, right? Plus 4 over there. Now the idea here is, technically speaking, right, this expression of f of x equal to k, we know that this being equal to k, if you say f of x equal to k, you end up with this expression here, minus 3x squared, write it better, man, write it better, x cubed minus 3x squared plus 4. This is equal to k. If you take everything to one side, you have x cubed minus 3x squared plus 4 minus k equal to 0. So the idea is, we know that you moving the graph downwards, we already spoke about moving the graph downwards, you see. We have to move the graph downwards, and it can only be moved a maximum of 4 units. So the effect of us moving the graph downwards is us having positive k values, you see. Positive k values will move the graph down. The reason positive y values will move the graph down is because you have a negative over there. So whatever k is, if it's a positive number, it will move the graph downwards. So we said here we have to, for us to have 2 roots that are positive and 1 root that's a negative, we can only move our graph a maximum of 4 units downwards, but it has to move down nonetheless. So here we can say that our value of k, technically, let's think logically here, k has to be an element of 0 until positive 4, where both of them are not included. The reason I'm saying that is because if you put a k value of like 0 here, your graph would not have been moved anyway. But then the moment you put a value of like any number that is bigger than 0 and smaller than 4, you're going to be moving your graph downwards, which is the scenario that we want. You see, we want to move our graph downwards, at least anything before, anything between 0 units downwards and 4 units maximum downwards, you see. That's why here we have to say that our value of k is between 0 and 4, because technically speaking, we are trying to say that our graph can be moved down a maximum of 4 units, but then this is saying that you have to move it downwards. So you have to say between 0 and 4 over there. And again, you see, if these kinds of questions still get to you and you don't understand and everything like that, then I do recommend that you sign up for like the functions and graphs course, because you see, you have plenty of questions like these that you can go through until it makes sense. And yes, there are videos and stuff on the course platform, obviously. I don't know, I'm laughing. Anyways, let's move on to 10.5. Determine the coordinates of the local minimum of g if g is this graph. So technically g is what you get after you have like altered f of x. So always start off with the original graph. You see, f of x here is equal to x cubed. Was that a plus? No, it's a minus maybe. Minus 3x squared, and then you have plus 4 over there. Plus 4. Now, the big idea here is with what they have here, right? They told you that g of x is equal to this thing here, negative x plus 3. What that means is in the equation of f, right, wherever you see x, throw in a negative x. And then to the whole thing, add a 3 afterwards, you see. So to the whole thing, you will need to add a 3 when you're done. So that's going to look like this. G of x, technically, wherever you see x here, throw in a negative x. So it's a negative x here, you cube it. Negative x here, you square it. There we go. You've done this green part, you see. Might as well color code it by doing this. You see, negative x, and then to the whole thing they said we should plus a 3. See, and then now we can just simplify this cubed. If it's a negative cubed, it always just comes out as a negative. This squared is gonna come out as a positive, and then 4 plus 3, that's gonna give you a 7. And then there is your equation of g of the x. You know, that's the equation of g of x. You see, nothing crazy, nothing major. I feel like I skipped the question here, but then they say, okay, they didn't ask us to just get the equation of g. They said we should get the local minimum. I feel like I messed up. But I actually don't. I think we can actually just carry on from here, because if you have the equation of g now, getting the local minimum, I mean, like, that's just one of your turning points, right? Let's see, did they say the local minimum? How many marks is it? 4. So I think we're still okay. The local minimum, so it's still just a turning point here. So for you to get your turning points, you know, you can still just differentiate once it equates to 0. So let's differentiate this. It's going to be negative 3x squared minus 6x. And then equating it to 0 to get the x values of the turning points, you're going to have negative 3x squared here minus 6x. And then factorizing here, I mean, yeah, do what you gotta do, man. Do what you gotta do. So these two x values here, let's see which your two x values here. Here, if you factorize, right, you're obviously going to get 2x values. So let's just see what 2x values those are going to be. Let's see here. The funny thing is, here you can take out let me just work it out. I'm literally going to use the quadratic formula, because I want to show you something funny. Negative b, let's see here, negative b, right, plus minus b squared minus 4, a is a negative 3, c is a 0, and then a is a negative 3. You see, so from here you're gonna have an x value of like negative 2, or x is equal to the other one. It is just going to give you a 0, you see. So obviously if you had factorized, here you can take out a negative 3 as a common factor, or negative 3x rather, and then here you're gonna have x on its own, and then here you're gonna have a positive 2, and then here you would still just be able to get these answers over here. But anyways, the idea here is you obviously would be wondering to yourself which two of these. Obviously you can just get the y values here to see which one is higher than the other one. So here, let's say here x is negative 2 here. Throw that into your equation of g of x. Let's see here, 3 negative 2 squared plus a 7. The other one, you're just gonna throw a 0 in there. So if you throw a 0 there and throw a 0 in there, it's gonna give you a 7, because 0 there, 7 is just gonna be left. For this one, it's not that simple. So negative 2 cubed, and then minus 3, negative 2 squared, and then plus the 7, that's gonna give you a positive value of 3. So you just check which one has the higher y value here. You know, this one is definitely going to be a local wait, what? Yeah, this is going to be your what you may call your local maximum, and then this is going to be a local minimum, because obviously the one that has a lower y value, that's going to be, wait, what, really? Yeah, man, I'm like, why am I even overthinking this? It's so weird. But anyways, this is going to be the coordinate of the turning point here. Therefore, -2 and 3. I genuinely think that this method may look long, but I think it's easy to remember. You know, I think it is easy to remember. So anyways, that is that for now. Let us just move on with the paper. Anyways, we have here question 11. Question 11 says the following. Use the information below to draw a graph of the function defined by this. Use the information below to draw a graph of the function defined by this. So anyways, here it says indicate the intercepts with the axis as well as the coordinates of the turning points for 5 marks. Okay, so this kind of a question, I mean, like, it's just interpreting a cubic function. There's a tutorial just like this on the main YouTube channel, because you see, if I go to the main YouTube channel, I think is it under calculus or under the functions and graphs? No, I think it's under the cubic functions playlist. So if I go to the cubic functions playlist over here, there should be a question on interpreting cubic functions. See here, using the first and second derivatives to sketch a graph. And I feel like, you know, there are different questions like these everywhere. Either on the course, I think on this channel as well, you know, there are different questions like these. But anyways, let's see. Here it says use the, we already read that. It says here we should use this to draw a graph. So let's see what they've told us. This is an x value of 0 and a y value of 3. So this is technically a y-intercept because the x values are 0. This is telling us an x value of -3 and the y values are 0. So this is technically just an x-intercept. Because you see, where y is a 0, that's the x-intercept. Where x is a 0, that's the y-intercept. So here this is telling you that in the first derivative, if you throw in a -2 and if you throw in a +1 in the first derivative, you get a gradient of 0. So here they've given you your turning points. You see, turning points. That's what they're trying to tell you. They're trying to tell you that you have your turning points there. So they've given us intercepts with the axes and then turning points as well. And then these are just coordinates that the graph passes through. Just random coordinates, more, or not random coordinates. These are the coordinates of the turning points, you see. Because you see, the x value here is a -2. This x value is a -2. X value here is a 1. X value here is a 1. This is telling you that the y value is a 5 for this turning point. The y value is a 1 for this turning point. So here this is like actual coordinates. Anyways, I think we can sketch this graph quite easily. It is out of 5 marks, so these are going to be 5 really good easy marks. So let us just get the marks. So in terms of sketching this graph, you see your Cartesian plane, you can just put that over there. I would put dotted lines for the turning points first. So this is like -2 and 5. So -2 and 5, that's going to be like somewhere there. So your x value is a -2. This is where one of your turning points is going to be. Let's just put a -2 there. The other one, x value is a 1. Let's put a dotted line over there. And then, let's see here. Y value is a 5, right? So you have, somewhere here you'll have a 5. That's where one of your turning points is. And then a +1, somewhere there, that's where your other turning point is. They told us that the x-intercept is a -3. So somewhere at -3 here, you have an x-intercept, and then y-intercept is at +3. So if this is like a 5, it means that the y-intercept is like down here somewhere where 3 is. You see? So let's put this coordinate here. The coordinate here is -2 and 5. The coordinate here is 1 and 1, you see. So technically, this graph, it's gonna come from there, turn, let's see here, it's gonna come from down there, turn over here, hit the y-intercept there, turn over there, and then carry on going up, you see. You're not a machine, so don't worry about writing or drawing a graph like this, you see. It's accurate. It's showing that it's a positive cubic function. It has a turning point over there, has a turning point over there, has an x-intercept, has a y-intercept. or rather has a y-intercept and has an x-intercept. Woo! What a nice 5-mark question. Let us just move on. For 2 marks, they said use the graph to answer the questions below. Determine the values of x for which this expression is a negative value. So there are questions like these, again, on the main channel, you know, in the inequalities playlist. There's a question specifically just like that one, like very similar, because if I go to playlists here, right, there's a playlist on inequalities here. If you look at these thumbnails here, something like what am I looking for? Yeah, I mean, like, there are different tutorials on questions like what they have asked us here, you know, just like this one here. If you look nicely, Ed, just skip, come on man, just finish. I'm trying to make a point, trying to make the point. Let me skip Ed here. You see, if you look nicely at this thumbnail, let me just move over to towards the end. You see this kind of a question here, you can see it's exactly like what you have. There's x here, there's something multiplied by f of x, you see. So that's how you're going to answer this question. This kind of a question, this is what they mean. They're just saying what will cause this expression to be smaller than 0. So you have a value times another value. Where will it be smaller than 0? For it to be smaller than 0, it means that this has to be a plus while this is a minus, or this has to be a minus while this one is a plus. You see, these two scenarios will result in your expression being a negative. So in our case, right, this is what we need to do to use our graph. They're basically asking us, where will you have x values that are positive together with y values that are negative, or where will you have x values that are negative while having y values that are positive? Because you see, this is just representing x values of the graph and y values of the graph. So you want a scenario where you have positive x values, but then you have negative y values. And you want a scenario where you have negative x values while you have positive y values. So let's look at our image and look for where that is happening. Here, you can see you have negative y values, but then you also have negative x values. So this point doesn't count because the x values are negative and the y values are negative. However, this portion here, right, what you want to think to yourself is you have positive, let me actually screenshot this so that I don't mess up this image. Oopsie, screenshot it, man. Screenshot. Let's screenshot. Oh, no, don't scroll capture, you thing. But anyway, scroll capturing is so underrated. Like, yo, this thing saves lives when you need it. But anyways, let me just grab this image here and then let's use it over here. Yo. Yeah, might as well do it here because we need the whole thing anyways. So with this image, right, obviously you want to look for cases where you have positive. Okay, let's start with this one because it's easier. You have negative x values while having positive y values, and that's happening here. You see, here you have positive y values, but then your x values are negative. So the portion that qualifies here is where x is an element of -3 until positive 0, until 0. Why am I saying positive 0? From -3 to 0, or rather we can actually include the 0 here, because here this is no, but it's the y values, the x values are 0 here. So if x is a 0, 0 times anything gives a 0. It's not like something smaller than 0. So let's see here. So here we have to say from -3 to 0 without including the -3 and the 0, because at -3 y is a 0. At 0, x is a 0. So if either one of these are a 0, it doesn't work out because we need an expression that is below 0, not equal to 0. So you see, this is saying x is between -3 to 0, And then this right hand side of our graph, this does not qualify for our answer because this has positive y values and it has positive x values. So that side of our graph definitely does not satisfy the inequality that we are required to just work out. So that's that for this question, you see. Let's move on to the next one. For 2 marks, they said if g of x is equal to that, write down the coordinates of the local minimum point of g. So where is f of x now? F of x is this graph here. Whoa, but then, okay, well, we're seeing the image, right? This is the turning point, this is the turning point. So we have to figure out what does this do. You see, this is showing you that your y values are all going to become a negative. You see, your y values are all gonna be multiplied by a negative, meaning it's a reflection about the x-axis, because if you reflect it about the x-axis, positive y values become negative y values and negative y values become positive y values. So this is basically reflection about x-axis, you see. So if it's a reflection about the x-axis, you know that if you're going to write down the local minimum, it means that this is the local maximum, it's going to become the local minimum. Like if you flip it over, the x value is still just going to be a -2, but then the y value is a 5 here. So when it's reflected down there, it's going to be a -5 instead, you see. So that's why this is just a 2-mark question. This is the kind of question that needs you to know your basics. So let us move on. Question 13. It's a 2-mark question. They said the word pandemic is an important word. Why are we talking about COVID-19? Even in tests, that's just so annoying, you know, just bogusness here. The word pandemic is an important word used in the COVID-19 crisis in the world today. The letters of this word are randomly arranged to form new arrangements of letters. How many unique arrangements of the letters can be made? Well, I mean, like, it is just 1, 2, 3, 4, 5, 6, 7, 8 letters, you know. 8 letters, I mean, like, the arrangement there is just 8 factorial because you have 8 slots, you see. 1, 2, 3, 4, 5, 6, 7, 8 slots. Here you can put one of 8 letters. The moment you put one there, there's 7 options left for the second one. The moment you put one there, there's 6 options left, going on and on and on until one option, you see. So this is just 8 factorial. And if you want, the number there is just 40,320. Nothing major. For 3 marks, determine the number of unique arrangements of the letters that are possible if each arrangement must start with P and end with C. That's quite easy. It starts with P and then it has 1, 2, 3, 4, 5, 6, and then it ends with C there, because that's like 8 letters in total. This one is quite easy because when all the letters are available, you have 8 options, but only 6 are available now. So here, the letters can be arranged in 6 factorial ways because you have 6 options here. The moment you put one there, you have 5 options there. The moment you put one there, you have 4 options, and then 3 options left, 2 options left, and then 1 option left. So here you see your answer is just 6 factorial because one is stuck there, one is stuck there. You only have 6 factorial ways for this question, which is just 720. 12.3 says calculate the probability. Now we're working on probability that the randomly chosen unique arrangements of the letters will start with P and end with C. So we already know that the number of ways that this can happen is 6 factorial ways. However, the total options without any restrictions is just 8 factorial. So this is the probability of getting a number that starts with a P and ends with a C, because you have 720 options where that happens, but then in total you have 40,320 options all in all without any restrictions. So the probability of starting with a P and ending with a C is just this value, which is 1/56. Question number 13. Oh, I'm so happy. So happy. Because this paper was kind of long, eh? Like, ish, yeah, ne? Whew. Number 13. It says, each passenger of ABC Airways flight chose exactly one beverage from tea, coffee, or fruit juice. The results are shown in the table below. So people that chose tea, mostly females, in total 60. Coffee, we don't know, but in total was 80 options. Fruit juice in total was 20 options, and then here in total males we have 60 males, 100 females. So they wanted to calculate the value of A. The value of A is quite easy because it's 60 males plus 100 females. It gives you 160 people in total. Very easy marks. They want us here to write down the probability that a randomly selected passenger is male for 2 marks. Well, in males in total we have 60 of them. No. Yes, we have 60 males in total out of 160 people. So the probability of choosing male is just 6 over 16, which is just 3 over the 2 there. That's quite an easy question. So let's just move on to the last question for 4 marks. The last question will probably have to get all the other variables there. It says given that the event of a passenger choosing coffee is independent of being male. Okay, so they said here choosing coffee is independent of being male. So probability of coffee is independent of being male. So independent events, we know that the probability of one thing multiplied by the probability of the other thing, this will always be equal to the probability of the one thing and the other thing happening. You see, that's for independent events. You see, because with independent events we know that the probability of one scenario times the other scenario, this will always give you the probability of the one scenario and the other scenario. So from that they want us to calculate the value of B. Where is B? B is over there. So anyways, here we just need to work out the probability of someone drinking coffee. Probability of coffee, let's see how many people drink coffee in total. It's like 80 people, so that's like 80 over 160. The probability of being male, we worked it out to be 3 over 8. So the probability of being male and drinking coffee, let's see what this male and drinking coffee, let's see, males that drink coffee, oh, we know it's just the probability of being male and drinking coffee, yeah, that's kind of tricky, eh? It's technically just B over 160. B over 160 people, you see. So we know that because these are independent events, this times that is equal to that. So we can easily work out B here, you see. Very easy question actually. 80 over 160 multiplied by 3 over 8. This should be equal to B over 160. Whew. I don't align, eh? Maybe it's just my brain, eh? But this paper was quite okay. I don't think there was anything very deep in this paper. I hope I don't sound too rude or too mean. I'm genuinely just giving my honest opinion. So this here, if you cross multiply, you're gonna have 16B and then 3 times 160. What is 3 times 160? I think I should have just looked at the questions first before I just dove into like doing the paper, because now I feel like I did this whole paper and it was not actually hard, eh? But hey, let me not offend anyone that found this paper hard. B is a 30 here, and then that will be that for this question paper. Woo! That was so amazing, so epic, so epic, so epic. That is all you got to know. This entire PDF, as I mentioned, you can download it via the link below. Everything that we have done here, you can just download it if you want it. And if you need access to the courses, you can always just go to the course platform. The link to that is also in the description. And if you have questions on this paper, you can just DM me on IG at LE_EVY. Anyways, hey, yeah, we've been working, eh? It's time to go and just relax, not a little bit. But anyways, that's that from my side. I will catch you in the next tutorial or wherever it is that you'll catch me. And then obviously, I mean, like, if you have not subscribed already, I'm like, what in the world? That is just weird. But anyways, this is the main channel, Bright Young Brains. And then obviously the channel that you're on now, it is the past papers channel, Metric Math past papers. So obviously if these videos are helpful and all that shandies, I mean, like, be the plug, you know, plug your friends, let them know. You see, this is the paper 2 version. It's already done. I can't believe I did the paper 2 first, but I'm going to upload this video just now. You'll find it on the channel. But anyways, for now, ciao. Wait, why doesn't this have a nice thumbnail? These people are lying to me. I put a thumbnail here. Anyways, let me go.